Hi everyone and welcome to this project. This project is an end-to-end banking customer churn analytics and prediction. In this project, I'm going to show you step by step the process for analysis and making a prediction for customer churn in a banking system. This is an end-to-end data science project, and it covers data analysis and data science and somehow analytics engineer scopes. In this project, we walk through all the stages, from the definition of the problem to the last step. But before do anything, I'm going to show you all the steps, the purposes of each step, and the language and tools that I'm going to use in this project. The first stage is problem definition. Problem definition should be in the first stage of every single project. Data science project must not start with lack of the business understanding. We should ask a question: why we are defining this project? Why we are going to use all these tools and techniques and all the meetings, data pre-process, data modeling, all these steps, why? We should define the business problem, what we are looking for. We should define the churn definition, what churn definition means in the banking system, and what is the success metrics in this project. In the next step, we are going to work on environment setup. If we want to work on the project, we should isolate the project that we are working on with a different project. In a real-world scenario, while you're working on a project A, maybe your colleagues are working on project B, C, or D. The environment should be isolated from each other. Why? Because one package that you're working on might not be useful for the other package that your colleagues are working on. And if they are integrated to each other and combined all the codes, all the dependencies, it makes a lot of trouble and mess. We should isolate the project, we should define the environment, and we should create reproducible project structure and environments for our project. Surely, for this section, we use Python language for creating the environment. For the next step, we are going to talk about data collection and understanding. Now we know the problem, we create the environment. We should try to gather data. We should collect the data, those data that are needed for this specific project based on a problem that we are going to solve. But gathering data is not enough. We should understand the data, and we should create a data dictionary. Why data dictionary is important? Because in every further step, we might need to come back to the data dictionary to see what's the definition of that metric, what's the definition of that features. We should understand it, and this is very important. The next step is data cleaning and feature engineering. It makes sense when we are working on a data. In a real-world scenario, we will have a lot of inconsistency in the data. We should handle missing values. We should deal with outlier, and we also need to sanity check. Sanity check, just give you a heads up, means if you're working on age should be a discrete number, or in some specific project should be decimal number. Age can't be string. These are some kind of sanity check that we should work on. Definitely, we can use Python language for this stage. Next step is about the data modeling and ERD design. Now we have the cleaned data, but we should make a data model. We should model the data, we should normalize the data, and design a relational schema for analytics, because we are going to analyze data, and analysis should be based on some schema that we are going to work on a relational data. In this project, we are going to use a structured data, and probably I'm going to use Snowflake's data schema. So definitely we can take advantage of SQL for this stage of the project. After that we have the schema for the project, we have the clean data, it's time to ingest data to the SQL. We can create a database, we can create a table, and ingest clean data to the SQL Server. In this stage, we should use Python and SQL. We push data from Python to SQL Server. Now we have everything in the SQL Server. Data is ready for some exploratory data analysis. Definitely, when we are working on a data, there are some ad hoc questions and some business questions that they are drivers for your project. We can use some advanced SQL queries to answer some important questions about the customer churn, about the data that we store. This is the place that all your stakeholders love this stage because they know the context and they can very quick capture the data. Now that we are happy with all this stage, it's time to turn a bit to data science. It's time to work on statistical hypothesis testing. This is the stage that I really love this stage because in this stage we validate churn drivers with the statistical evidence. We can run some statistical test and hypothesis testing and do some statistical inference to understand what is the relationship between the variables, which relationship are drivers for the other, and what is bringing impact on the target. We can use Python in this stage, and specifically we can use some packages like SciPy and StatModel. Now that we know the statistical testing and statistical inference behind the scene, it's time to go to machine learning stage and predictive modeling. We can build and evaluate churn prediction models. We can run hyperparameters tuning to tune the model. We can build a model, test it, evaluate it, and all this stage are going to be done with Python in this step. Now we can go to the next stage. In a real world scenario, only building a machine learning model is not enough. Even if you build a model with 99.99% accuracy. Why? Because we should understand how the model is working. Is it fair or it's not? Which feature is the most important feature? Or other metrics. We should do some model governance and responsible AI metrics here. We should evaluate the fairness of the model. We should evaluate how biased the model is. We should run some explainability metrics for the model, and we should analyze the risk of the model. This is very, very important before deploying the model. However, in this project, we are not going to deploy the model, but this is the preliminary step before deploying the model. And we can use Python again in this stage. And the last stage, that is the stage, again, your stakeholders will love it. It is data visualization and storytelling. This is very important stage when you are going to communicate insight to business stakeholders, because business stakeholders doesn't understand the machine learning model, doesn't understand the statistical testing or all the technicals and coding behind the scene. It makes sense because they know the insight. They want to see the final result. And this is the stage that all our steps are going to push to. And we can take advantage of Tableau for this stage. So guys, this is the full journey that I'm going to walk through step by step in this project. From problem definition to data visualization and storytelling. So let's get started this project. All right, let's talk about the business context for this project. As I told you, this project is about customer churn prediction. And the first step is that we should know the initiative for this project. We should use the historical data to drive the retention and protect the revenue. This is the initiative for the project. The banking managers for this project want to use historical data to drive and lead the retention and protect the revenue for their own business. This is the main initiative for this project. Before going to details, let's talk about the summary for the business context. First, we talk about the challenges that the bank right now is dealing with. After that, we talk about the solutions. Which kind of solutions we can take advantage to tackle those challenges. And finally, we go with the outcome, which we want to find them as a final result of the project. The challenge that bank is facing is that growing number of the closed accounts currently managed through the reactive measures that fail to prevent revenue loss. It means right now the banking is witnessing so many customers are closing their account. They are closing their account, they are leaving the bank, and they're going to other banks. And these pattern will reduce the revenue for the bank, and in future they fail to prevent that revenue loss. In terms of the solution, we are deploying a machine learning initiative to predict customer churn using historical data. As I told you in the previous sections, we have so many different goals for this end-to-end project, but the main solution for solving the challenge is making and deploying a machine learning models to help managers to predict those customers before leaving the bank. This is the major goal for this project. And the outcome is definitely by identifying the high-risk customers early, we will enable some target retention campaigns and try to convince those customers before leaving the bank. And we can improve the customer lifetime value, or CLV, which is crucial for banking system. So customer retention is the primary battleground for profitability. Profitability is very important when we are working at the finance industry, and customer retention is one of those. For context, banks operate in a highly competitive markets when customer retention is critical. You know that in every single country there are a bunch of banks and they are doing the same tasks, but they are in a competition. And they should know this competitive market. They shouldn't lose their customers. Economy reality says that acquiring new customers is significantly more expensive than retaining the existing one. Based on a benchmark, cost of acquisition is 5 times more than cost of retention. It means when banks want to acquire customers, they should invest and cost a lot to acquire new customers. But if they want to try to keep the customers satisfied and try to retain the customers, the cost of difference is much, much less. And the consequences is that when customers leave the bank suffers from the loss of recurring revenue, increase the marketing cost with no replace, and finally it reduces the customer's lifetime value. Our current approach to churn is reactive, not proactive. This is what manager says. It means right now we are just sitting at chairs and see the customers are leaving the bank. We are just reacting. But we should do some proactive. It means before they leave the bank, we should know and try to do some campaigns and convince them to not leave the bank. So the reason is that for this project is that changing the mindsets and the systems of the bank from reactive to proactive. You see here the operational gap. At one point, the customer decides to close the account. And after that, they leave the bank, they want to open the bank account in another bank. But we missed opportunity window. It means before customers makes a decision to close the account, maybe for 2 months, 1 month, 3 months, they are thinking about it. They started to think about the closing account. Before to the moment that the customers decided to close the account, the bank should know. And this is the goal for this end-to-end project. If they want to do some proactive, this is the best point. But right now, everything happens after the customers close the account. And this is some kind of reactive, which is not useful. So first is observation. The bank observes the growing number of the customers closing their accounts, and after that, the operational failure, because the customers left the bank and nothing is important after that. So in the bank, we lack visibility into the drivers of customers' attrition. It means we should find some drivers. What is convincing the customers to stay in the bank? We have some knowledge gap. Currently, there is no clear understanding of which customers are more likely to churn and what factors contribute most to their decisions to leave the bank. And the resulting in the blind spot. Without this data, retention efforts are just generic. And it is just the actions that they are not useful and they are not timely mannered. We miss the customers, and it doesn't matter right now, we know why the customers left the bank. So the business problem is, how can we identify customers who are likely to churn and understand the key drivers behind their decisions? This is the main business problem. So we must bridge the gap between the data and decision making. This is the main goal for this end-to-end data science project. So project objective is that predicting churn through historical data analysis. We have some historical data. After that, we do some exploratory data analysis, we do some prediction, and everything behind the scene. And finally, churn risk identified. So primary object is to predict whether a customer will churn using historical customer data. And a strategic intent is this shift at the bank stance from waiting for account closure to anticipating to forecasting them based on the data pattern. It is exactly the place where data comes to play and help managers. This project is going to show us data is not just wrangling data. Data is not just making a model, beautiful dashboard. We can help managers to extract a bunch of information behind the data's pattern. So generating actionable insights with driver strategy. We should identify the drivers, pinpoint the key behavioral and demographic drivers of churn. After that, we can enable the actions, provide some actionable insight to support retention strategies, and empower the teams. We can support data-driven decision-making for marketing and customer success teams, which are pretty important for banking system. So we have project objectives and goals, and we have the strategic intent that we talked about it. So success is defined by reliability and interpretability. Technical success is that reliable churn prediction model that we are going to build it, which should be equal with business success. It should be interpretable, the insight and business stakeholder. It means the model that we are going to build, it's not just gonna be a model, perfect model with 99% accuracy. It should be understandable for managers because it's gonna be some handy tool for managers to give them some insights, because all the banking stakeholders or all the project stakeholders are not the technical people. They know some things, but we should give them some business context to them. That's why the business success should be equal with technical success. So the model must not only work, it must be understood by the business to be useful. So moving to proactive retention will protect revenue and improve targeting. But how? With early identification, we can flag high-risk churn customers before they leave the bank. In terms of the efficiency, better targeting for retention campaigns, which kind of campaigns I can use. Revenue protection, which makes sense. Reduce the revenue loss due to the churn. And finally, lifetime value. Improve customers' lifetime value. These are 4 important targets as the monetary or the financial target. And finally, empowering key stakeholders across the organization. For marketing retention team, they can take advantage of this project. For CRM team, definitely, because they are going to enable the proactive outreach, and executive decision makers, which are managing the bank, and they should know at a high level visibility for the organizational health. In the last slide, I'm going to show you what we are standing right now and where we are going to go. As a reactive section, we are just reacting to the churn detection, but we want to be proactive. We have unclear drivers. We don't know what happens when customers decided to leave the bank. But after this project, we should have the clear behavioral insights. Revenue leakage, right now we are dealing with, but we want to maximize customers' lifetime value. So, this initiative provides the necessary intelligence to secure the bank's customer base in a competitive banking market. So this was the problem statement, which are the initial and the critical step for doing an end-to-end data science project. All right, now it's time to go and do something in action. If you remember our roadmap for this project, after defining everything, the problem, the goal, the objective, and the problem statement, the project initiative, it's time to roll up the sleeves and do some technical things for our project. In every single data science project, before doing anything, we need to create the environment. Environment is very important and plays a pivotal role in every project. Why we need to create the environment? If we don't have the environment, and just assume you are working on 5 different projects, if you don't have the environment for each, the codes, the libraries, the packages, and their dependencies might intertwine together, and it will make a lot of mess on your project, inconsistency in the versions, libraries, and so many things. That root cause and fixing those kind of issues is kind of hectic. So it is suggested that for every project, you need to create the isolated environment and install all those packages, libraries in that environment. When you need to update one library, which is specifically useful for your project and not for the other project, you can simply go to that environment and upgrade that libraries. You might have 2 different pandas libraries as a version. One project is using pandas version 2, the other project must use the pandas version 3. So you should handle these conditions. So it is suggested to have the environment for all the projects that you're going to work. Our project is not exception. So we need to have the environment for our project. You see here, we have the workspace. Workspace is a whole container. It means everything is included here. Our workspace is called Bank Churn Project. Here, I just put one test Python code for testing the environment. After that, when we see everything is working properly, we can safely remove this document. So first thing is that I'm going to create the environment and I'm going to install Python to my environment. Please note that you should have Python installed on your machine. If you don't have the Python, you should have it. And after that, you can assign that Python to the environment. It means creating the environment doesn't mean install the Python. We should have the Python as a base container and just make an image from that Python and install in our project. If you're working in a company, definitely they have the Python, but you need to use that Python and install it as your environment. So I go to the terminal, I press Control, and we see here, we are in a terminal section in a workspace which is called Bank Churn Project. To create an environment, there is very simple code. I write it down, Python, because I'm going to install Python in my libraries. And after that, I say M just to mount it. Virtual environments, and what I'm going to call it, I'm going to call my env. It means I'm going to create virtual environment, which is called my environment, and it is just an image, a mount of Python. All of this environment is going to be installed in my workspace, which is called Bank Churn project. I press enter and just wait. You see in the left bar, now we have my environment. This is all the necessary Python packages that they are the basic package. It means right now we have access to Python, not libraries. For example, right now we don't have pandas, we don't have NumPy, we don't have all the different libraries, but we have Python. And all the scripts are there. Okay, now it's time to activate this environment. We just created. We should activate it. So I go with this code. I put dot / and I call my environment my environment. Again / I'm going to select this file active BAT. So I should go to the scripts as a folder. Inside it, I will have activate.bat. Just make sure everything is right. My environment, the folder of the scripts, and inside the scripts, I'm going to call activate.bat. If I press that, it means now my environment is activated and I can install whatever I want or work with it. Okay, now it's time to make a decision as a data scientist or data analyst. You should make a decision how you're going to interact with the Python code. Somebody would like to do everything on a terminal, just what I'm doing right now. They can see the results in a terminal or whatever. Somebody like me want to see the result as an interactive window. Most of the time, usually the software developers are going to use the terminal because they are not considering every single code in the environment. They just want to see the results. They are going to run a script with 1,000 lines and just see the results. So in that case, CLI or the terminal PowerShell is the best solution for them because it is so fast. But as a data scientist and data analyst, this solution is not useful because we would like to work with every single code differently. We would like to see the result before going to the next code. It's not just useful to see the final result. I prefer to use the interactive window. Interactive window means that I'm going to work on a code. After that, I select that code and just run it. It means this is regardless. It is totally independent from other codes in my script. This is so useful for the data scientists, data analysts, or everybody is going to work on line by line, not the final result. But working with this scenario needs one library which should install in our environment. So let me show you right now what it happens. If I go to the connection test, I'm going to run it. This is just, it's going to show me whatever I have in my environment. If I run it as an interactive window, means I should press Shift and Enter. You see, it is asking me we should have one library as an IP kernel package in our environment, which is called myenv. I can simply install it here, or I can close it and I can close it again. I can install that library in my environment and after that run that code. So installing the library is super easy. I go with dot / select my environment. After that, I go for scripts, and now I should select Python .x. I'm selecting this file here. Now I should use the pip install. I say pip install. What is the name of the library? It is IPY kernel, and I press enter. The bank, maybe something is not correct. Oh, I forgot. Yes, I should copy. This is the live code, and it makes sense. We have some error. forgot to put that one. Okay, now we are installing IP kernel. It means after installing that IP kernel, you see the IP kernel now is installing here Jupyter everything. It means we can interact with our code. But how can I test it? Before testing that, because I'm going to use the interactive in a VS Code, we should assign my username for these libraries. It means I should activate that library. Okay, for assigning, I need to paste that code. Let me explain it. It means we went to the Python executive, I selected the IP kernel installed, and I should assign the user name, and the name of the environment is my environment, and I just call it as a Python my environment. If I press it, now the IP kernel is installed in my system. It means now if I go to this part, previously when we ran it, we saw error. I selected as the interactive, Shift Enter. Okay, you see now we can simply use the import sys just as a testing whether we can work with interactive or not. You can see now my system, instead of showing that IP kernel, it's showing the path for the Python. It shows the interactive now is working. Before going to that section, I prefer to talk about the pandas. You know that the pandas library is one of the most useful libraries that every data scientist or data analyst is going to use that. Because we are working on a data frame as a structured data in our project, we need to have the pandas. But right now, I'm going to see whether my environment has pandas or not. If so, show me the version. I press Shift and Enter to see, but it shows I don't have pandas. And it makes sense because in our environment, we just install the Python, and after that, the IP kernel. We don't have anything as a pandas here. So we should install the pandas library. How we can do that? I close the interactive window and go to the terminal. Okay, here I'm going to say, go to my environment, the scripts, Python execution, M just for mounting, and pip install pandas. I'm going to install pandas in my environment. I press enter and just wait till pandas is installed successfully in my environment. It takes time a bit because pandas is a package with so many things. So now it's installed. If I close it, go to interactive window, and I'm going to select again whether right now my system or my environment recognize pandas or not. I press it and just wait for first time pandas. Pandas is a bit heavy library. It takes time to load it for our environment for the first time. We are just waiting. Wonderful. We installed pandas library at the version 3 because I selected if you install it, show me the version. Just test it whether it works or not. I just create a data dictionary. This is the data. If you would like to see it, this is just a dictionary. But as you know, we are working as a data scientist. We need to see the data frame. I convert that simple data as a data frame with pandas library and just show the result. Wonderful. We are working with interactive side by side. Each code that I would like to see, I just select it and run it. We don't need to run all the code to see the result. This is the magic of interactive window in VS Code. Okay, now I would like to close the interactive. Okay, and close the environment. Right now, we need to make the structure for our project. Based on the project that we are working on it, we need some folders and subfolders. It makes sense during the project, you might delete some folders which is not useful, and maybe when you wanted to create the project and create the structure, you said, okay, I need that folders and subfolders, but after that you made the decision, no, it's not useful. But at the initial step, you should have the structure for folders and subfolders. Based on our roadmap for this end-to-end data science project, I just categorize based on these folders. I would like to have one folder as a documentation. And inside that folder, I would like to have two subfolders. One of them is for documents, and one of them is for figures or any images that I'm going to use in our project. Another folder is the data. In the data, I will have two subfolders. One of them is the raw data that we just captured from every single sources for capturing the data. And after that, we will have one subfolder for process data, which is the clean and very organized data. Another folder, I will have scripts. And inside the scripts, I have one folder for data cleaning scripts. One folder is for data ingestion scripts. I have another folder, separate folder, as EDA queries that we are gonna put all the SQL queries inside this folder. Then I have one notebook folder as statistical testing. We would like to have put all the statistical testing inside this notebook. Maybe even I don't need that one, but let's have it. Then we have the predictive modeling folder. Inside it, we have one folder for building ML, just for training the model, test and evaluating. One folder is for responsible AI, to see how fair the model is. Do we have any bias or any error in terms of the explainability? And the last folder is for data visualization, which we are going to use one BI tool. As you can see, we have so many folders and subfolders here. If we want to use manually, definitely we can, but it takes time and it's not the professional way. We can use pathlib library, which we don't need installed as a separate library because it is the pre-built libraries inside the Python. It means when we create the environment with Python, this library is installed. But Pandas was different. Pandas was a separate library that we needed to install it. But pathlib, we have it already. I just import the pathlib, made a list as a folder, I put all of them, and for every single of them, I'm going to use the make direction. I select all of them, and even that section, or let's go one by one. I select the pathlib, go with the interactive, pathlib is installed, and I select the folders. Let's see what do we have inside the folders, all the things, and now, and I select it. You can see right now we don't have anything here. As long as I run this code, we see the result. I see, and you can see all the folders that I created are here. Scripts, we have 2 folders, predictive modeling, 2 folders, notebook, we have a statistical test inside it. My environment is for the environment, EDA queries, documentation, data visualization, and data. So we successfully structured our project, configured everything that we needed, and we made the environment and isolated the project. Definitely during the project, if we need one library that we don't have it, we can do the same process. We can open the terminal and install that library. But the good thing is about right now, if everything is done and we want to push everything inside the Git, we can create a Git ignore those files that we don't want to push. If we want to deploy the model, we can make a Docker file to containerize all these packages and push it to the deployment environment. We can create a requirement text for those libraries that we need because we have very, very isolated, containerized project. However, in this project, we are not going to deploy, but this is just for hint that our project is super flexible right now. All right, now let's go and talk about data. Data is the basic and the most important part in any data science project, and we should be very careful about data. We should understand it in depth, and we should know the relationship between the tables. Here we have 3 different databases for our project. It means in this project, we are going to gather data from 3 different databases in our company. Maybe they are 3 different departments, or they are using different data mart or data warehouses, anywhere. We need this information, and we should categorize based on 3 different databases or data sets that we are going to deal with. First, we have demographic. For demographic, we will have some columns. We will have customer ID, which is the unique value for each customer when they registered in the bank. We have name of the customer, which is the string. We have gender, age, salary, and location ID. Also, we have another column. Location ID is here the foreign key, which is coming from location table. As you can see in the location table, we have location ID as a primary key, and we have geography, which is country, as a string. In the right side, we have account data. And we have account ID, which is the specific unique ID for each account. We have tenure, or how long that account is active. We have balance, how much the account is balanced. We have number of the products, is active, or this account is active or not. Has a credit card, means this account has a credit card. Churn, this is the target column that we are going to with it in this project, whether this account is churned from the bank or not, and customer ID as a foreign. If we want to see the relationship between the tables, we can see we have the demographic, and each customer ID might have multiple accounts. And each location ID might be repeated more than once in the demographic table. This is very, very simple, a data model, but it is very important for our project to have it. This is just the data that we gathered, but we should take a look at in depth how we are going to deal with this data in our project. For having better understanding about the data, we must have data documentation or data dictionary in every single project that you are going to work. Personally, I don't start any project as long as I have the data dictionary. Data dictionary is the document that you should refer to it more than once, more than several times in a project. Because you should know if you have a problem, if you have a question about the columns, what kind of treatment you should apply for that column. If this is numeric, the story is different. If it is categorical, the story is different, and anything else. We have the column name, we have description, data type, and level of measurement. Data type is how data is shown to us, and level of measurement is how we should deal with that specific column. For example, customer ID is unique identifier assigned to each customer at account creation. The data type is integer, means this is a number, but level of measurement is label, means even though this is a number, we should consider it as a label. Why? Because those numbers doesn't have any mathematical definition for us. They are just a number, but they don't have any specific meaning. Name is a preferred name of the customer. This is a string and this is a label. Gender. Gender is a string, but it is categorical nominal. Means even though they are a string, we have some categories. But those categories are not any prioritized. Means, for example, male or female is not more important than the others. They are just a nominal categorical. We have estimated salary. Estimated salary is just estimated annual salary of the customer. This is decimal. It means we might have some decimal or float number here. And this is numeric, and this is continuous. Age of the customer is an integer. It means we shouldn't have any decimal. It is just a rounded number. So this is numerical, and this is discrete numerical value. Location ID, as same as the customer ID. This is integer, but this is just a label. Geography, like the gender. This is just a country where the customer is residing, and this is a string and categorical nominal. Account ID is just a label. Tenure, just number of the years the account has been active. This is integer, and this is numerical discrete. The balance, current balance of customer's account at that moment. And this is decimal, like salary. This is numerical continuous. We have number of the products, means number of the banking products or service linked to that account. And if you want to see which kind of products every single bank has, just Google it. For example, the bank that I have account, I have 5 or 6 services mapped to my account. This is integer. It should be just one number without any decimal. Makes sense because this is number of the services. And this is numerical discrete. We have one column that has a credit card, indicates whether the customer has a credit card or not. This customer means the account of the customer. For example, if that account is mapped to link to the credit card, the value is 1, otherwise this is 0. So this is categorical binary. And is active member? The same. if that account is still live, it is still active, it should have the value as 1, otherwise 0. And the churn is our target column for our project, indicate whether the customer has churned from our bank or not. Please note that this data is not the live data for the bank, because if this is a live data, all churn is 0, because we have live data from the customer, means the data is still for customer, as customer is still receiving data for us. This is a historical data. If you remember the definition of the project, we have in a problem definition and problem statement, we are using historical data, and it makes sense. So now we are very, very familiar with the data. We can start working on a project in the next phase, which is data cleaning and data preprocessing. All right, now let's do some data preprocessing and data cleaning for our project. In the left side, you can see the structure for my project. This is the structure that I prefer to have. In this specific section of the project, we are going to work on those 3 data sets. We are going to first write some functions and then apply those functions on every single data set to pass through all the tests that we want to have on the data. Which kind of tests we want to apply on the data? First of all, we should do some sanity check. Sanity check means, for example, if the columns is categorical, the values should be in the range for the categorical. For example, if the gender, we have female and male, we shouldn't have anything else in the list. Or if we have, for example, 10 values as a unique values, we shouldn't have more than this or even less than this number. So it means during this process, we might refer to our data dictionary many times. It's a kind of back and forth to pinpoint if there is any issue about our data. That is why I said having the data dictionary is very important when you want to work with the data. The next function that we are going to work on that is dealing with data type. It means just because the data frame might have 10,000, 20,000, even something million thousand, or even something million number of the rows, you can't see all the data, all the rows with your eyes. You should rely on some libraries such as Pandas or Python libraries to find the data type. For example, if you're working on age column should only have number. If there is anything else in terms of the type in the age column, the function will show us, and it means we should deal and tackle that condition. The next function that we are going to work on that is null value. Null value is always very harmful for the project, specifically when you want to work on some machine learning and giving insight and data visualization for your stakeholders. So we will have one function to tackle this condition. And finally, we should work on outlier. Outlier is another important thing, specifically for numerical values or numerical columns in our data. If I say categorical and numerical, I'm referring to the data dictionary that I just showed you. In the data dictionary, we mentioned which column is categorical and which column is numerical. Okay, the first thing is that I go to the script folder, and here we have something, data cleaning, data ingestion, and utils. I go to the data cleaning, and here we have nothing. So I create a file and name as functions, and it should be Python file. This is a Python file that we are going to work on that file. Okay, now it's time to start create those functions. The first thing that I'm going to do is just put a comment, and I say import or say libraries. These are the libraries that we are going to work on them. The next section, we are going to create function. The first function is that categories sanity check. The next function, again, the function is that data type checking. The next function is that null values checker. So the next one is that function for outlier detection and distribution. These are the functions that we are going to work on them. The first function is for category sanity check. Let's see what does this function shows us. For this function, we need a data frame. It means one of the arguments for this function is passing the whole data frame. After that, we should mention which column we are going to check the categorical features for. For example, it might be column age, it might be column gender, or anything else. And finally, we should say for those columns that we mentioned, what kind of valid value should have. For example, if it is gender, the valid value is only male or female in our specific project. For different projects, we might have different values. After that, we have everything here. We should make a new data frame as an invalid data frame. This data frame is all the data frame that we have, except everything which is in value. What does it mean? For example, let's say for gender, we have female, we have male in the value list. This is our list. But if in our list in this section, if we have one value as an X, which we didn't mention as a valid list, this data frame is one row, and that row for gender has the X. Because X is not, this mention is not in the list. And finally, just count how many rows for each rowing value. For example, how many for X, how many for Y, and different things. These are some values which we didn't mention in valid value here. This is the first categorical function. Later, when we apply this function, we will see how they work. Okay, the second function is data type checking. Data type checking is working like this. First of all, we give the data frame as one argument. And after that, we should have a dictionary. And in that dictionary, we should mention, for example, for column A, this is just a dictionary. Column A should be a string. For example, for column B, it is, for example, integer. And so on and so forth. After defining the dictionary and the data frame passed through the function, we create an empty dictionary as a mismatch dictionary. And then we said for every single column and the D type, in the dictionary that we made it here as an item, it means we are going to, just because this is dictionary, we should select the item. One by one, each of them, column and D type or the data type, for each of them. If the column was in the data frame column, which should be, and that column data type was not this data type that we expect, put them, all of them, as a new dictionary in the empty dictionary that we set. For example, we expect column A should be a string. But if this function finds the data type of the column A as an integer, this list will capture column A integer. Why? Because integer is not what we mentioned as a string. This is how this function works. Okay, good. And we can go to the next function to see how it works. Okay, next function is super easy. We have just one argument as a data frame. Then this data frame is going to return the null values. If this is the null values, just bring the summation, how many number of the rows are null values. Then combine them as a two frame, as a missing count, just add a column name, and then assign the lambda function to just find the percentage of the missing values. For example, if a column has 12 missing values, the length of the data frame is, for example, 1000. The percentage for this number is 12, almost, I guess, 1% or something. And then the query is that the missing count, if the missing count here is more than 0, it means if this is the 0, it means we don't have any null value. If the query shows that if this is more than 0, means at least we have one missing values. I said later when we work on a real data and apply this function on the data, we will see how the function works. I'm just introducing the function and later we apply those. And the last one, we have some kind of outlier detection and distribution. First of all, this function is only for numerical columns. And we pass the data frame as one argument and column. Then we make the histogram to see, for example, if this is the normal distribution, it shows something like that. And this is the KD, it means we need the density. We don't need the bar shape for the histogram. This is a very simple function, just shows the histogram for every single numerical column. And the last function here is another kind of useful visualization or chart for numerical column, which is box plot, shows the outlier. If we have any outlier, this function is going to show us. Even though the histogram can show, I prefer the box plot because it shows very, very handy, and it shows exactly in which part we have outlier. And it shows the quartile, and the median, the mean, the maximum number, the minimum number, and IQR, so many different things. All right, now we have our functions. All of them are ready. But you might ask question, how we can use this function to apply for our data? Before going to that, let me show you the data that we are dealing with. As you can see, we have here as a folder data, and we have raw data. You can see we have raw data Excel file. This file is shown here. You can see we have demographic. I just put it there. We have demographic. We have almost 10,000 records. We have location, just 6 values for different locations. And this is location ID. Location ID, here is location ID. And we have account, all the information about the account. We have customer ID, account ID, tenor, balance, so on and so forth, that we saw in the data documentation purposes. Okay, right now I'm going to apply this function on the data to try to clean data if they have any of these issues. Okay, I go to the data cleaning in this folder. I'm going to create another new script. I click on that and create demographic.py. The process that we are working on it is called modular and reusable. Why this process is useful? Because we are going to use and apply the same function for as many as the number of the sheets that we want. It means if we have different issues, we just need to work on one function instead of having same function in different script. In that case, it's not reusable and it's not consistent. But the modular process, it means when you want to tweak a formula or tweak something in a function, if you fix it, all the scripts that are using that function, all of them have been affected. So for demographic, first of all, we need to import the libraries. But before that, I'm going to say which kind of process that we want to have. Let me just bring it. We need to have this section as a category sanity check. We have data type check. After that, we will have null value checker. And the next one is outlier detection, this process. But before that, we need something else. We need to import libraries and packages. We need to load data. These are the initial steps, and after that we can check it. Okay, let's go one by one. First of all, I need to load the data. The libraries and packages are being filled during whenever we need it. Okay, the first one is load the data. Loading the data means we are going to read this raw data here. I create a base direction, and after that we should use pathlib. So it is the time that I'm going to import one library. This library is called pathlib, and it is very useful when we are working on different folders. We want to refer to that folder, read file, and so many things. So first of all, I'm going to import this library. After that, I'm going to find the base direction. What is my base direction? For my project, the base direction is this section, bank churn project. So from this file that we are here. We need to go one level up to this section, one level up to this folder, and after that, if we are here, we are in level 4 bank churn project. It means we need to come back as 2 parents, and just because parent here is 2. If I run it, for example, if I select it and just run it, I don't see the path type. I can just select it. You see the path direction is bank churn project that we are. It means that if whenever I call the base direction, I'm here. And after that, just because I'm in the toppest level of the container, whenever I want, I can go. I don't need that section, I can remove it. Okay, now we are here. We are going to go to the raw data. How we can go? This is super easy, just with 2 pieces of code. First, what is the file name? The file name is here, raw data XLS. What is the data path? Data path is that whenever we are, it is the base direction. After that, go to the data, and then go to the raw data, and here what you can see, I see the file name that we mentioned here. This is the path that we can reach the data. This is the professional way. Why? Because it is super flexible. When the file name is changed, you don't need to change anything. For example, if the name of this project is changed, just because this is parameterized, you don't need to change anything. The only manual process is that you can do this, the data and raw. Even for these two, you can create some directions at the parent level 1, level 2, or level 3 to parameterize everything. It means now if I select these two and I go for data path, you see this is the data path for my project. From the base direction, I go to the data, then raw, and then raw data XLS. This is the Excel file that we have it here. But we don't need the Excel file. You see the name of the script is demographic. We only need the sheet for the demographic section. So we need to go into details. First of all, I say what is the name of the sheet. The name of the sheet is demographic. And how we can read the data? Definitely with pandas. You can say import pandas as PD. I only select this section and run it. Now with pandas, we use the Excel file. And with the Excel file, we mentioned this file that we just reached to, and which sheet? This sheet for the demographic. Now, if I run this section, I select both. Where is the data? I just close it. Data is here. Just select the data frame. Wonderful. We reached to our data frame super flexible. If I change it to, for example, accounts, the only thing that I need to do is just select it and run it. Now we reach to the account. I prefer to go to demographic because this is the place that we are working on this script. Just select the data frame and run it. Now the data frame is ready, we can apply different functions to check whether it needs any pre-processing or not. Okay, let's start with category sanity check for this data frame. For category sanity check, this is the function. Let me give the space a bit so we don't get confused about different functions. This is the function that we are going to work on for sanity check. But this file is in a different script, and this function is in a different script. How can I use here? This is the place that modular functioning comes to play. In the library and packages, if I open it, you see the function that we define. This function is next to the demographic. So they are in the same folder. So the only thing is that I go to the demographic, and here I can say from the name of the file, from functions, import name of the function. That's it. This is done, and just import it. Now the function is here and we don't need to write it down again. If we do any changes here, all of them will apply automatically. We don't need to write this function for different scripts. One same function for different scripts. This is just wasting the time. And now I can use this function and say this function needs 2 arguments. One is the data frame that I have it. The other one, let me just give a space a bit. The other one is name of the column. Let's see which column these dataset for demographic have, and we need to check as a category column. If you remember the data dictionary, we should only work on categorical column, not integer, not label. The first categorical column is a gender. So I select the gender and put it there. But which kind of values based on a data dictionary these column must have? Based on the data dictionary, this column only must have 2 data types. I make a list and say, first of all, it's female. The first one is male. The second one is female. It means based on definition for that function, we talked about it. It should go for the gender. And if any row is female and male, it passes because it is okay, done. But if it finds anything else except male and female, it shows the flag and bring back one data frame with that wrong values. Everything is done. I can select it and run it. We see nothing. It means there is no issue about the gender. That's the good news. It means all the values we have here are either male or female. But do we have any other categorical column here? For age, this is numeric. Salary, it is numeric. And location ID. Location ID is a number, but it's not numeric. It means 2, it's not less than 6. This is just a label. But this label is different with customer ID. Why? Because location ID is a key. Do you remember the ERD, the relationship diagram? We should have the location ID only in the list 1 to 6. Why? Because we just have 6 countries based on the data documentation. We shouldn't have anything except 1 to 6. We might have nothing for number 2, that's fine. But we shouldn't have anything for example, number 7 or number 8, because we don't have any country in our, the ERD or our data model for that. So I select location ID here and just replace with gender. This is very reusable and modular function. And here the list, instead of male and female, we say 1, 2, 3, 4, 5, and 6, because value should only be one of these. I select it and run it. Again, we see nothing. That's amazing. We only have these values. What about the churn? Churn is the same. We only, based on a data dictionary, we should have 0 or 1. So I select 0 and 1, and we can double check. Again, nothing. That's amazing. So it means the demographic data set, in terms of the sanity check, they are totally fine. We can go for the next one. I push it down and go with data type. Let's see and talk about the data type. I just make it a bit clear, and again, select the data frame to everything to be clean and neat. Okay, here for data type checking, we have this function here, data type checking. Again, I need to import that function. I say from function import validate dtype, and paste it there, select it, and run it. Now the function is here. I need to use that function. I go to see how many arguments it has, just copy and paste it there. Okay. We need to have two things. One of them is data frame. The other one is expected dtype, and it should be dictionary. But where it is, we should create it. So I go before applying this function and create a dictionary. So this dictionary is here. We might have a dictionary like this name, expected dtype, and it is exactly the same as the argument. Which kind of columns that we have, and we want to check the data type. For customer ID, just because this is a label, it doesn't matter. It can be anything. So we don't check the customer ID. For the name, again, it can be anything, but I push it down. For name, I go, name should be a string based on the data documentation string. The next one is gender. Gender should be a string again, that I put as a string. The other one is age. This data type that I'm adding here, this should be based on the data model. We're going to check whether the real data is the same as we want or not. Integer should be integer 64. Sorry, age should be integer 64. Salary should be numeric, but it should be float or decimal. In a Python language, the decimal is called as a float. Location ID, it should be integer 64, and same for churn. Churn should be integer. These are our dictionary. I just created the dictionary, and let's see whether our dictionary is working. Okay, this is exactly what we needed, and we need to apply this dictionary on a data frame. Based on the definition of that function, if any of the columns have different data type, it shows. Okay, now it's time to run the function, but here we don't need the dictionary. This is just for our knowledge that we want to have as a dictionary. So I select it and run it, and we see nothing, and this is very good news. It means the data type in this data frame is the same as we expect based on our data model and data dictionary. So no issue for data type checking. The next function is for checking null values. Let's see how we can work with null values. Again, I need to import the null values, and this is missing values here. What is the function? We only need one argument as a data frame and put it there. Let me just clear the data frame that we have it. We pass it. Let's see, do we have any null values? Let's see the missing. Oh, I didn't import it. Now let's see. Okay, we have 0 missing values. No missing values and no percentage makes sense. So this is good news. It means demographic data is super clean. That makes sense because we just extracted this data from the real, not real, semi-real data warehouse. So it means the data is very clean just because it's coming from the data warehouse. And data warehouse, as you know, is cleaning data all the time. So null values go to that section. And the last one is outlier. Let me check for outlier. I copy, paste it there, clean it. For outlier, we have 2 things. Plots distribution. And the next one is plot box plot. I just import these 2. Let's read the data frame again. And let's see what these 2 function needs. The first one is plot distribution. Plot distribution needs 2 things. Name of the data frame that we have it, name of the column. But as you know, the distribution is only useful for numerical column. Which kind of numerical column do we have here? We have age, definitely. I can copy age here and paste it. And it should show me the distribution density based on a kernel density. Okay, I just pass age to this function and let's see what happens. We see the age distribution is a bit right skewed. It means we have some outlier or a big outlier. It means we have some customers, they are much older than the most of the customers because the median is almost between 30 and 40 years old. And it's not too bad, but during the data modeling, we should consider this one. And it might be a little important when we want to talk about the responsible AI for data modeling. Let's go with another function, which is for box plot. The box plot is here, and I just copy and paste it there. Box plot is the same, just see in terms of the box plot to see the outlier much better. You see here, it's a bit right skewed and it makes sense because we have some outlier. The maximum, if this function is following the normal distribution, the maximum is almost 62 or 63. After that, all of them are outlier. Even we have one customer, the age is more than 90. But we can't remove it in this specific project. Why? Because in this project, at the final stage, we need to have some BI tools. And in that case, we shouldn't remove any data. Another reason that we don't want to remove the data is that just because we have lack of data. If you want to remove these customers, we will have lack of data and it's not very useful. So I prefer to keep this one and proceed with this condition. Now we check everything for these data as the demographic. But let's see the data frame again. These are the columns. And I think we don't need name as the column here. So I prefer to remove, I can say remove columns. I say data frame. And I'm going to remove the name for the customer because it's not going to bring any important things for us. So I say df.drop, and the name of the column is just a name. And I don't need that column. And the access should be 1 because we are working on the column. So I select it. And now this is our data frame without the customer. Okay, now we have the data frame ready, and I would like to export it as a final and pre-processed version for demographic. I'm going to save this file from here that we are to pre-process as a destination for that file. If you remember, we have the base direction for our project, and this is referring to this section. So based on that, I'm going to just say export file. I'm going to make export direction. The export direction is the base direction. then go to the data, and then go to the processed. This is the base for output direction. If I select the output direction, you see the output direction is referring to that folder. This is ready. The next thing is that I'm going to refer the file name. Which name I'm going to save the file? I'm going to save the file as a demographic CSV. And this is a file, and I would like to save it. And the next step is that file path. This is the path of the file. It should be the output direction. And after that, we will have demographic CSV. And now I can simply save and push data in that folder. With this simple CSV code, I say data frame to CSV, where to this section, the file path and the index should false because it's going to be reindexed. However, we didn't remove any rows anyhow. I just index as a false. I select everything and run it. You see the demographic CSV are here, and this is the processed CSV file. Very clean and very neat. We checked everything about this data frame. Now we worked on demographic, and demographic is ready. And just because we have the modular, we need to change all the code for the location and for account, or we can make a copy and tweak it. I prefer to keep this file and make a copy from this file and tweak it based on the other data set that we have. This is the magic of writing the modular formatting. That's why I prefer to work in this scenario instead of working with a notebook. Notebook is useful when you want to report and making some documentation for the process. But if you want to work very efficiently, I guess Windows Interactive in VS Code and writing the modular programming and object-oriented programming is super helpful. So we are ready to go ahead and work on the other data set, which is accounts. Create a new script, and this is account.py. Whatever I need, I only need to copy from the demographic and paste it here, and I don't need it. I first want to import the libraries because they are the same. Now again, I go for read the file. Instead of demographic, we should work on the account. And just write it down, see the data frame. Data frame now is for the account. We see all the columns about the account. We have account ID, customer ID, tenor, balance, number of the product, has credit or not, is active or not. These are the last one. I sit there. Okay, let's go one by one. First of all, sanity check for categorical column. Which kind of categorical column do we have? We have customer ID, no, number of the product, no, because based on the data dictionary, this is the numeric. But these two are categorical binaries. So this one, we expect only to see 0 or 1. So I write it down to see. Yes, exactly. We just have 0 and 1. What about this one? Same, nothing else. So it means in terms of the categorical sanity check, data is super clean. In terms of the data type checking, for account ID, this is just the ID. I don't want to check customer ID. I don't want to check for tenor. For tenor, based on the data dictionary, it should be integer 64. Balance should be float 64 because it has some decimal. Number of the product, it should be integer. Have credit, it should be integer because it should be 0 or 1. And is active should be integer. And I don't need the last one. This is the expected D type that we would like to have. And now if I run the validation to see, we got nothing. It means the data type here are exactly as we expected. Now let me clean a bit space and just see the data frame again. Now we can go with the checking the missing values. I select this function and run it. Okay, we have missing values in which column? In balance. In balance, we have 3,617 missing values. Almost 36% of these columns are missing. We should deal with this condition, but before dealing with this situation and tackling, I prefer to see the data distribution and see which kind of strategy we can apply for these missing values. So let's see for outlier detection. For example, for tenor, let's see, do we have any outlier? Just apply for those. No, we don't have any outlier, and it is some kind of uniform distribution. That makes sense because the lowest number for the tenor is almost 3 years, and the highest is almost, the lowest is 0, and the highest is 10. The median is 5, so it means data is super uniform. About the balance, however, we have some missing values here, but let's see the distribution. It's almost normal distribution, however, it has some outlier. But again, this project, we are not gonna deal with outlier. Dealing with outlier is totally different projects, and because it needs different technologies and different methods, this is far beyond the scope of this project. So the next one, let's just bring the data frame. The next one is number of the products. See, number of the product. Number of the product, we just have 4, but just because we have very few number of the labels, that makes sense, and it shows we are good. And has credit, this is just 0 and 1, and if the active is 0 and 1, they are not numerical column. Let's come back to the missing values. Okay, let's see again the shape for distribution shape for missing value for balance. This is normal distribution, and it means just because this is normal distribution, we have some techniques for dealing with the missing values. The basic one is we can impute the missing values with the mean. Because we are having a normal distribution, we can use the mean as the imputation technique for dealing with the missing values. So here I add one more step as dealing with missing values. Let me first clear it and just show the data frame. Okay. Here I'm going to use this code. This code says for data frame in an imbalance, I'm going to replace this column with a new column which doesn't have any missing values. Why? Because those missing values, all of them are mean for the balance. If I select only this section, this is the magic of interactive window function. I select only this function and see. The mean or the average for the balance column is almost 190,000 something. It means we are going to replace this number instead of the missing values. And after that, we apply all these ones on a missing value. My new data frame should have the balance, and if I run it, my new data frame is here. Now let's see how it works. We don't have any missing values. Why? Because we fill all those missing values with the average. Okay, I guess here just because we have customer ID, which is the key between this table and demographic, we don't need account ID. So I select account ID. This is the column that we don't need it. Customer ID we needed, tenor, and all the rest we needed. I don't need that column. And this is the final columns, and no missing values for the balance. Again, everything is okay. I just need to set account CSV, and if I open it, right now we only have demographic. If I select everything and run it, now we have account CSV also here. This is clean and neat data. The last one is super easy because this is just the dimension table. let me just create a new script as geography.python. I copy all of them and paste it there. Okay, what is the name of the sheet? The name of the sheet, if I'm not mistaken, was geography, but let's double check. Name of the sheet is location. So this is name of the sheet. So I go here, everything is fine. I can select everything. And here I should say this is gonna be location. And if I select it, yes, we have the location data frame here. In terms of the categorical, we just have very few rows, however, we can double check, but it is just wasting time if I write down the Germany, France, Spain, UK, Canada, and USA, because we can see the data frame is not too big. We don't need this one at all. In terms of the data type checking even, we can see all of them are string, so we don't need that function here. Missing value, again, we don't need the missing values. We see whatever we see here. In terms of the distribution, definitely we don't need it because we don't have any numerical column. So we don't need to dealing with missing values and we don't need to remove any columns. Only thing is that we should say this is location as a CSV and put it as a separate file here. We have 3 CSV files. This is why I really like modular programming and window function, because you have super flexibility to work with this data. So this stage of our end-to-end data science project is done. It was about data cleaning and data pre-processing. In the next step, we are going to push all this data into the SQL Server and do some queries. All right, let's continue the project to the next phase. In this step, we focus on ETL process. We are going to push all the clean data to the database and store the data in a secure place. In a real-world scenario, this is the correct way for storing the data. Because right now, we have the clean data in this folder as the process data. But it's not the safe place. Data is always prone to change, and it's not the secure and professional way for saving the data. The data is not secure in terms of the data privacy and every single thing. We should store data in a place which is very secure. This is the database. We need to push data to the database. So in this stage, we are going to do that. After this stage, whenever we need the data, we don't call data from the folder. We call data directly from the database for exploratory data analysis, statistical testing, machine learning, and even for BI or the data visualization stage. Okay, so the first thing is we need to go to our database. I'm using Microsoft SQL Server for this specific project. And as you can see right now, I don't have any database. So the first step is that in the server, which is called SQL Server, I'm going to create a database. And after that, we should connect this SQL Server to the Python. So let's go and create a database. Okay, I go and create a new query. And here, I'm going to create database. And name of the database, I'm going to call bank Churn. And then I go for Go. This is for SQL syntax in Microsoft SQL Server. The database is created. I go to the server and just refresh the server. And we see the database is here, bank Churn. But inside the bank Churn, there is no table. We need to create the table. But which kind of table we need it? If I come back to the process data in a Python environment, you can see we have 3 different CSVs. We have locations, we have demographic, and we have account. So we need 3 tables inside the databases. So I come back to the SQL Server and just delete it. I don't need that one. Okay, I should say use the bank churn and then go. It means I'm going to use this database. And I say this is create demographic table. For demographic table, we need to go with create table, open, close parentheses. Inside the parentheses, we need to go with the columns. What? We need name of the database. I go with, let's go with small demographic. This is the name of the table that we are going to build. But what is the column for this specific table? Please note that the column name here must be matched with whatever we have it in CSV file. Because later we want to push data from CSV with all the metadata they have to this table. So those metadata should be matched with each other. Otherwise, we will encounter error. So I go here and open the demographic. These are name of the CSV file. I copy all of them and come back here. So this is the customer ID. The next one is gender, age, salary, location, and churn. But we need to do something else for creating a table. We should say what is the data format for each of them. And if the data format again is not matched with the data which is going to be pushed to the table, we see error. If we come back here, let me just copy just first example and paste it there. For gender, we should have the varchar. I go for n varchar, and I think gender is just male and female. I go with 10 characters because it's not more than 10 characters. Age should be integer. Salary should be decimal. And decimal function has two arguments. The first argument is that how many numbers is in the left side for the salary. I don't think so there is somebody that salary is more than 8 digits. I go with 8. And the decimal, I think 2 decimal is enough. Location ID should be integer. And churn is 1 or 0. So it is bit. Okay, let's 8 to 10 to stand on a safe side. But one of them is left, which is customer ID. Customer ID here is primary key, and we should be careful about it. Because if we don't set it very carefully, when we want to push the data here, we will see error. Why? Because the SQL Server is so sensitive about the primary key. And primary key, as you know, the main characteristic is that they are not changeable. So first of all, the data type is integer, definitely. And it is primary key. But we need to say it should be identified as a primary key. So I say identity is 101. Identity is 101. It means this is the customer ID, this is primary key, and it's not changeable at all. This is the table that we just created. Okay, now if I simply select it and execute it, you see the command completion successfully. If I go for a database and refresh it, the table should be here. And we see the demographic table is here. If I open it, definitely there is nothing because we have not pushed it yet. The next table is exactly the same for the process. I just copy and say create account table. I call it as account and go here and open the account. Just bring the first row as an example. Okay, we have customer ID again, but here customer ID is just the value. It's not the primary key. So I say customer ID, and it should not the primary key. It is just the integer number. The next one is tenor. Tenor was how many years the account is active. It should be integer, and definitely integer doesn't have any arguments. The next one, I just remove it to make it clean. The next one is balance. I copy balance. Balance, as you can see, is a decimal number. So I need to copy, paste it there, 10th digit. That's fine. And for the rest, we have 3 columns. This is number of the product. It should be integer because one account might have 5 or 1 or even 0 service account linked to it. This is number of the product. And the next 2 columns, both of them are bit because they are 1 or 0. That's it. And now we created the customer ID as an integer, tenor, integer, decimal, integer, bit, bit. So I select it and run it. Again, if I go there and refresh, we have the second table, the account, just open it, nothing is there. And the last table is just geography table. Create location table, and I call it as the location. Just because location is a saved name, I go with that naming. Location is here. We have just 2 columns. The first one is location ID, and the last one is geography. Geography should be varchar. I go with 15, and again put inside the bracket because geography is a saved wording or saved function in SQL Server. I select it, but I forgot that this is primary key, and identity 101. And just execute it and refresh the database to see where is the table. We have 3 tables: account, demographic, and location. Definitely there is nothing inside them. Okay, here our job is done. We don't need to do anything here. We need to come back to Python to push the data inside these empty tables. Okay, here I need to go to the scripts and go to the data ingestion. I'm going to create a new file, and I would like to call it as a SQL connection.py because it is a Python file. What we are going to do here, we are going to push the data to the SQL Server. Okay, first of all, I should read the data that I have. And again, I can use pathlib library, which is very helpful and handy. So again, I say libraries and packages. I need to say from pathlib import paths. This is the library. I'm going to just select it to run it. Okay, the library is there, and I'm going to go to the data that I saved. We are in the script section, data ingestion section and script section. I'm going to go to the data section. So I say load data. First, find the direction. The direction is the parent one. Let's see what we can see. If I selected, pass, I didn't select, that's it. We reach to a script, we reach to here. So I need to change it to 2 to see where we can go. We are in this section, which is exactly the place that we needed. So base direction is in that place. Now we are here and we need to go to the data processed and the data that we need. But before that, I should set what is name of the file. Name of the file is demographic CSV. This is the first file that we want to push it. And now we have name of the file. So we need to complete and finalize the path, the entire path for the file. So this is entire path for the file. If I select this section, let me just close it a bit, make a space. I didn't select the file name, and that's it. We are reading the bank churn data process demographic.csv. We are happy with it, so I store all of them as a data path. Now we have path of the file. Now we can read it with Panda libraries. So before going with Pandas library, I should say import Pandas as PD. I just import it. And then here I say data frame read these paths that we just set it here. Set the data frame. Let's see the data frame. This is exactly the data frame for the demographic. Now we would like to push this data to the empty table that we just created in the SQL Server. But how we can do that? First of all, we should create a connection. So I go for, say, create connection. Here we need to use one library as a PyODBC. So I need to import that library. Import just this one. And please note that if you remember when we created the environment, I said during the project, whenever we need the new library, we need to install in the environment. Before I start the project, I installed all the packages, all the libraries to save the time. But these are the list of, if I would like to show you the list of the packages, these are all packages that we are using in the project so far. During the project, you see this list is gonna be more complete. But after that, if you want to deploy your model, you can use this list for creating the environment when you want to Dockerize and containerize your project. Okay, now we have this library. I need to import it. And this is my information for SQL Server. It might be different for yours, but the drivers is for SQL Server. My server is Mehrdad // SQL Express. The database is exactly the database that we created, bank churn. And trusted connection should be yes, because I'm using in the same computer. So I just select and run it. If I see the connection, it is exactly just a connection message. So next, we need to create a cursor. Cursor is very important when we are working in Python and we would like to talk to SQL. Because cursor means it's a kind of bridge between the Python and SQL. Now, cursor for us is connection.cursor. That's it. I save it, and this is our cursor. We have connection, we have cursor. So what is the next step? The next step is that push the data. I say push data to database. And this is the code. Let me explain the code. We say in demographic table that we just created for customer ID, for gender, age, salary, location ID, and churn. Value might be anything, but it should be some kind of for loop for every single index in the file that we have for data frame. It should iterate every single row. And for each of them, cursor is going to insert those kind of values, whatever they might be, in this order to the SQL. If you're familiar with SQL, You know that we are using this kind of syntax for inserting the data to the database. But if you want to do it manual, we need to do it 10,000 times. So instead of doing manual, I use for loop as an iterate row for every single row in a data frame. And after that, everything is ready, we need to commit. But before doing that, we should make a match between order of the columns and the data type. If I come back to the SQL Server, if I open just the demographic, go to rows, you see we have customer ID, we have gender, age, salary, location, ID, and churn. If I come back here, we have exactly the same naming, even this is case sensitive, the same naming, and also the data type. Customer ID should be integer, gender is a row, means just some kind of a string, integer for age, float for salary, integer for location ID, and integer for churn. So, and after that, we need to commit. But if I run this code, we see error. Why? Because customer ID, if you remember, was the primary key. And SQL Server, because of the data privacy and security, doesn't allow to change and modify the primary key. But how we can solve this issue? Before solving that issue, let me put a print because I'd like to know if the process is done. I'd like to receive a message that process is done. So I put data inserted successfully. Okay, how we can deal with that primary key prohibition? So there is very simple code. Before pushing the data, we need to say the cursor execute set identity insert for demographic table should be on. If this is on, the SQL Server allows us to push the data. And after that, we commit or just update the connection. I prefer to put it here. And let's see. Okay, we updated the cursor, that's fine. I updated this section. Now we are able to push data to the database. So I select all this stage and let's run it. It takes time because we have 10,000 rows, so fast. Data inserted successfully. If I go to the SQL Server, just close it and refresh the database. Go to the table. Previously, we didn't have anything. Let's see what happens now. Wonderful. I just selected top 10,000. You can see we have exactly the same values that we have in CSV file. And this time, instead of having data as a CSV format here, we have it in a very, very secure place as a database. Whenever we need the data, we just call from the database. We don't need to read the CSV file over and over again. This is the first table. We can go to another table, which is called location. I close it and go to the location section. So I call it push demographic to database. Let me clear it. Okay, this is for pushing the demographic. I can modify everything for different purposes. I copy everything and paste it for pushing location to the database. But before that, we need to read location CSV. So I select location. Let's see, the name is location, exactly. Okay, I put location. Let's select it. Let's see whether the database is location. Wonderful. I update the cursor. That's fine. This is for demographic, so I don't need the demographic. I need to go to the location section. I need to say this is what is the name of the table is location. So I say just location should be on because location has a primary key also. I update it. And what is the data type for location here? First of all, let's update it. It should be demographic. So we have only 2 columns. Here, if I select the location, we have location ID. Let me copy, paste it here just as a note. We have location ID, and we have geography. These are my column name, exactly the same as what we have in SQL Server. So location ID is just the integer. That's fine. I updated the location ID, and geography is just a row or string. Location is very, very small, just as a 2 columns. Just double check everything. We have location, location ID, geography, 2 location ID is integer. Okay, everything is done. Just run it. Data is imported successfully. Let's come back and just refresh the database to make sure everything is working correctly. I just select it and go for location, and that's it. Wonderful. And the last table is account. Okay, we have nothing because we need to push the data. I select everything from this section and go there. Push account data to the database. Name of the table is account. Account here. Okay, in terms of the number of the columns, I bring everything. Let's go one by one, update it. Let's make it as a comment. Okay. First of all, the first thing is that customer ID. Customer ID is here. Next one is tenor. Oops, it should be tenor. The next one is balance. The next one is number of the product. Next one is has the credit card or not. And the last one is active or not. These are number of the columns. But here we need to set some data type. Customer ID, we have integer. Definitely this is integer. Let me plot from here, just as an example that we have it. Okay. Customer ID is an integer. For tenor, if I come back to the Excel file, you know that tenor is an integer file. So I need to copy just one integer and paste it here as an example. And tenor should be integer. The next one is balance. Balance is a decimal number, so it should be the float. So it is float and balance. The next one is number of the product, and number of the product again can be integer. So number of the product. The next one is has the credit or not. Again, this is integer. And the last one is as same as the previous one. Oops. Is active or not, 0 or 1. So we don't need it. Just review. We have accounts. We have account here. Number of the column. They are exactly the same. Okay. The only thing is that we need to update the data. Just clear. Let's read it. The data frame is the account. We have tenor, balance, and the scorecard is active or not. Just update the connection. And let's go for this section. First of all, it doesn't have any primary key, so we don't need to update it because this table doesn't have any primary key. It is reading the customer ID, which is the primary key for the demographic table. I only need to push it to the database. Oops, we have error. Let's see what's the error. The SQL contains 2 parameters markers. Oh, here we have 1, 2, 3, 4, 5, 6. It is only 2. 4, 5, and 6. That makes sense. I select it and just run it. And data inserted successfully. Now if I go there and just refresh, open the table and open the account. Wonderful. Let's just give a test. For example, I would like to have select customer ID, tenure, and balance from this table, but I'm going to join it with the other table to see whether the connection between table is working or not. I call it as A or account and demographic as a D, and they are gonna be joined based on a customer ID. Customer ID is equal customer ID, one from D, one from A. And here I say this one is coming from A. Just make it a bit clean. A. This is the way that I like to have. And this is the accounts. And this is demographic. Customer ID. Okay, wonderful. We have account for, let's run it to see what it has. Okay, we have 2 tables. And I'm going to join with demographic table. A as a customer ID and D as a customer ID. Let's see if it works or not. It works. And I need to have one column from demographic to see whether it's working or not. For example, I'm going to bring gender for the client. Gender. And the other one is just the location ID. The location ID. Now let's see, it works. Perfect. Even the diagram, if you remember the EDR diagram, it is exactly working based on that. Okay, so let's see whether it is working based on a location ID or not. So I go for join and with location. This is L and on. Okay, if I go with location, location ID is here. So I say location ID for D is equal location ID for L. And here I'm going to have just geography. Geography. Oops, geography. I hope, oh my God. Geography. Okay, let's run it to see. Okay, database is perfectly working, and you see, very simple, very delicate, and very seamless. We imported the data from Python to SQL. And the good thing is that this file, like as all the files that we have worked so far, this is modularized, and this is very flexible, and this is based on object-oriented programming. If name of the file is changed, you just change it. If anything else changed, you only need to work on this file. However, there are some rooms that we can more parameterize this document, but at this moment and for this end-to-end data science project so far, I think that is enough and that is fine. So we imported data to the database, and the next step is very interesting section. All right, let's start exploratory data analysis with SQL. Let's start with the first question. Okay, I go for the new query, and this is the first question. The first question is asking which customer profile have the highest churn risk rate based on a gender. If I would like to simplify, this question is asking find the churn rate based on each gender. First of all, we should know what is churn rate and how we can calculate. Churn rate means number of the churned customer divided by total customer. This is so simple. And after that, we need to calculate this number per each gender. I start, first of all, use the database that we are going to work on. And I run it to make sure we are working on the database that we want. Let me just increase the size a bit and just give it space. Okay. First of all, I'm going to select the columns that I needed. I go for select. If I open the database, and I should see the ERD that we just made it in the second phase of the project. You see, the project is super integrated with each other, which looks like a real data science project. We should always come back to the previous sections to see the data documentation, because all the project is based on a data documentation and a stakeholder's needs. Okay, I need to go with the gender. The gender is in demographic. So if I open the columns, the gender is here. So I select the gender from the demographic table. Now I have the gender, but I need to have also churn. So this is the second one. This is gender, and this is the churn. So let's run it to see what we have. We have very simple. We have the churn and we have the gender. I didn't bring the customer ID because I need the granularity of the project based on a gender, not based on a customer ID, because customer ID is the key. And if I have a key, the grouping doesn't make sense at all because data has the highest number of the cardinality. So what I need here, I need to go with the sum of the churn based on each group. So it means if I would like to group by data based on the gender, I can just make a sum for churn, and I call it as total churn. Okay, now let's run the code to see. Okay, we got an error. Why? Because it said the data type is bit, which is invalid for sum operator. If I just a bit make it wider, you see churn is bit as a data format. It is 1 and 0. And aggregation functions doesn't work for this kind of data type. But it's not very difficult. We only need to cast it. So I cut it and say cast this column as integer. It means right now we change the data type for churn from bit to integer. And after that, we can just simply make a sum for that column. You see right now, female has 898 as the churned people, and female has 1,139. It means most of the customers who churned are female. Okay, I need one more column because I need to have total number of the customer in the demographic. So I go for count everything as total customer. And if I run it right now, we have total number of the customer. You see, the male has the highest number of the customers, while it has the lowest number of the churned people. It is totally in the opposite direction. And we can make the divide, the total churn divided by total customer. So by doing that, I prefer to put everything as a CTE to make a code a bit clean. So I go there and say with, I say main table, just it's clean main table as, and inside here, I would like to have my code. Paste it there, that's it. Just gender and everything. We have CTE here. Now I can just select everything from the main table. I have everything here. Now I have flexibility here to work on the data, because if I would like to add more codes here, it might be a bit complicated. Okay, here I need to have everything. Also, I need to have one more column, which is just a simple divide. Total churn divided by total customer. Okay, if I simply say total churn divided by total customer, and I put it inside the parentheses as churn rate, this is 0. Why? Because both of these numbers are integer. And in SQL language, integer divided by integer is always 0. We should just simply say this one multiplied by 100. It means right now we have 16% and 25%. It means out of all the customers who are male, 16% of them churned. Whereas in contrast, out of all female customers, almost 25% of them churned, which is very important for the banking managers. Maybe they should run some campaigns and something to convince the female customers. Maybe the other banks, our competitors, are doing some campaigns and they have more interesting packages for female customers. But I don't like this format, and I would like to have as the format and say this format I would like to have based on N2 format. And now if I run it, let's see what we can find. We have now 16 as a percentage. I just need to add plus just percentage. Here I guess. And it should be inside the quotation. Now if I run, it is more beautiful for managers if they want to see. Okay, we simply answer the first questions, and here we used one of the most popular and most important functions in SQL as a group by and aggregation functions, which are pretty popular and common. We can go to the next question. Okay, the second question is say, how does churn rate vary across customer segments within each geography? Again, this question is about the churn rate, and that makes sense because our target for this project is around the churn, and this is the most important object for our project, and there are a bunch of drivers for this specific target. So for this specific question, what we are looking for? Okay, this question might be a little bit challenging. For this question, we would like to first to see in which country or in which location, and inside that country, in which age group, what is the churn rate? And then we need to compare that churn rate with the average churn rate in that specific country. For example, let's say in Canada, the average churn rate is 25%. But we would like to compare this 25% with the average churn rate for all Canadian customers who are in a specific age range. For example, maybe the age range for 13 to 50 is higher than the all Canada average churn rate. Because it doesn't make sense if I check and compare the average churn rate for 13 to 50 years old in Canada with France, because maybe the customer behavior is totally different. In each country, we would like to compare the average churn rate for a specific age category with the average churn rate in that specific country. So based on my explanation, we know that which kind of data we need from the database. We need the age, we need the location, and we need the churn. So the age is in demographic and churn in a demographic, and location is here in location table. So first of all, I would like to select from demographic. I would like to have age and churn. This is the column that I needed. And I need to also have location. What is the key between the demographic and location based on ERD? This is location ID. So I say it should be join location on location ID. Oops, location ID is equal location ID. For location, I call it as a L, and demographic I call as a D. So age is coming from demographic, churn is coming from demographic, and geography or the country is coming from L. I would like to call as a country. Okay, let's run the code to see what we have. We have age of the customers, we have whether the customer churned or not, and we have the country. But this age doesn't work for me. Why? Because if you see, age here has very high cardinality. It has very high unique numbers. And I don't like that. For example, the average churn rate for all the Canadian customers who are 39 years old doesn't make sense if I would like to compare it with 38 years old. We should make a bean. We should binding the data. It's a kind of data engineering process. So instead of the age, I would like to add one more column. And I would like to use the case with function here. I say case and say end as, I call it as an age group. Inside it, let me just make a space. Inside it, I would like to say when the age is less than 30, then just put under 30. This is just one section. Then I can say when age is, for example, between 30 and 50, I can say between 30 and 50, and else just put above 50. This is our just data binding. Instead of the age, I would like to have the data binding based on under 30, above 50, or any age between this. If I run this code, you see now we have one more column as an age group. So it means I don't need the age anymore because I would like to have age category instead of the age. So data is ready to go ahead and do something on that. Okay, again, I prefer to put all this code inside a CTE. I say main table as, and I would like to have all this code inside my CTE. If I just simply select everything, just check whether our CTE is working or not. Okay, it works. Now we only need to work on this section from now on, because I don't like to have very, very complicated code. In that case, fixing the bugs is very difficult. Okay, here what we are going to continue. I'm going to have first total number of the churned people. Okay, here what I'm going to have. Here I'm going to have first total number of the records, whether they churned or not. And after that, average of all people who are churned. So first of all, I'm going to have age group. I'm going to have the churned. And the other one is the country. The other column that I would like to have is count all the rows. Let me put something like that, which is more makes sense. Okay. So let's run it. We need some kind of aggregation function. It makes sense. But our aggregation function should be based on the country. And then based on age group. And right now, I don't need the churn. Let's run it to see what we have. In age group, let me just put the country first. It is much better for interpretation. In Canada, in age above 50, okay, now even I would like to order by, this is to have everything inside. In Canada, in age group 50, we have 217 customers. I can say total customer. However, from 30 to 50, we have the highest number of the customers, 1,191. And under 30, we have 271 customers. And we have the same categories for the different countries, for France, for Germany, and for Spain. If they don't have that specific category, they don't get 0. It means they don't have it. Okay, now it's time to find the average rate, average churn rate, based on each country and each age group. It means this is the lowest level for finding the average rate. Again, I can use the average for churn. Where is the churn? Churn is here. But as you know, we need to just cast the churn. Cast the churn as integer. And I call it as average churn rate. If I run it, maybe if I need to change it to float to don't get 0. Okay, this is much better. For example, here, average churn rate for the customer above 50 years old in Canada is 49%. However, average churn rate for customers between 30 and 50 is 18%. And for the customers who are young, the churn rate is almost 7%. This is a good hint for the managers. It means for almost senior people, when the people get aged, they are more willing to churn from the bank. And it might be a little good hint for managers. Let's see, for example, what about the France? The France is the same almost. And what about Germany? In Germany, it's the same, and almost Spain. So it means this company should try to have some services that young people try to love it. It means this bank should have some packages and services that senior people don't want to churn from the bank. Maybe most of the services that this bank has is suitable for adult people and young people. And that's why in every single country that we are seeing, most of the senior people want to leave the bank. And you know that the definition of the problem, leaving the bank means a higher churn rate, and it is less lifetime value and less revenue for the bank. Okay, but here I need to find the comparison between every single age churn rate category, right now we have it, with the overall countries category. How we can find that? It means right now I have 3 average for Canada. But I need one more column, which is average of this average. This is the average for the country. And meanwhile, I don't want to lose the number of the rows. It means I don't like to say, okay, if I would like to have the average for the Canada, I can make a CTE for this file, make another query, and make the average from the rest of the table. In that case, we lose the dimension of the table. We lose the age group. That's why right now I would like to use the window function. Window function is very, very helpful when we don't want to lose the data dimensionality. If I just make an average from, for example, in Canada, if I make an average from above 50, between 30 and 50, and under 30, that we have the average right now, average of this average is average of the Canada. So I copy this and make a new row. Here, I would like to say, I would like to have average of something over, it's kind of partitioning, over by country, because I would like to have the country at the highest level for making the average. And it should be partitioned by country. And I would like to have, this is average churn country. And which kind of average I'm looking for? I'm looking for to average of this one. It is some kind of average of average. Let's run it to see what we can. For example, here you see for every single row for Canada, we have the same number because it makes sense. We are in the level of the country. In the level of the country, for churn rate in Canada is 22%. But in Canada, the above 50 people, they are almost double more than the average of the Canada. For example, in France, the for average for the country is 23%. And you can see, again, above 50 is more than the average of the France, and under 30 is very, very less than the average of the country. It means right now, we have not only the average rate within each category, we have average rate across the country. Now we can make it just a simple save as. Now, what I'm going to do is that I'm going to cut everything and put as the second table as. And I would like to put everything here just as the new table. If I would like to go and say select everything from the second table, let's see what we have. Okay, let's see what's the issue here. We can't have order. That makes sense. In CTE, we shouldn't have the order. That makes sense. Okay. Right now, I only need to have everything, and I would like to make a delta, or the differences between the average country and the other one. The average country minus average churn rate as just an if, and let's run it. If we want to see only the -1, simply we can use the where condition to only keep the difference. But right now, you see almost for senior customers in every single country, the average churn rate is more than the average churn rate for that specific country. And it means the bank has problem for making the services and convince them to stay in the bank and not churn to other banks. This is very useful information that we could capture from the window function for these specific questions. Okay, now let's go to the last question for exploratory data analysis in our end-to-end data science project. This question is asking, how does churn behavior change when we dynamically slice customer by business parameters? It means the managers want to have a list of the churn customer with some information, and they would like to play with some parameters. This question shows in a data science team, you're not alone. You're not just working as a data scientist or data analyst separately. You need to work with software developers. You need to work with different departments for these specific questions. Why? Because you need to make a SQL query, and after that, you need to pass this query to software developers to make an application for the managers. And then managers just simply add 3 numbers in that application, then submit the button, and then they see the results. This is the integrated platform. Managers definitely don't want you to run the query in front of them or in your laptop. They can just simply sit down next to you and see the code. No, they would like to have the result in their phone or the mobile or in the systems or laptop, anywhere. They would like to just run a code with a simple button. They don't want to see the code. This is why we should learn how we can parameterize our queries. In this specific question, I would like to show how I parameterize a simple query to help managers to find the data they needed as soon as possible. Okay, let's start. First of all, let's see what they need. They need a list of the customers who churned, and this tables is going to be filtered based on some parameters. But what are those parameters? For banking system, for this project, 3 parameters are super important for managers. This is tenure, or how long, based on the data model and data definition that we have, how long a customer has been with us, what is the amount of the balance they have in their account, and how many number of the products that are mapped and linked to that account. So it means we have 3 parameters. One of them is tenure, the other one is balance, and the next one is number of the product. Please note that more parameters, less number of the records. Why? Because we are adding more filter on the data. So here we have 3 parameters. Okay, let's first run the query, and after that we can go and parameterize it. Okay, I need to first select all this column that I need, and all of them are coming from the account. I need one more column as a customer ID because managers want to see list of the clients, so they should have one identifier as a customer ID. And I need to have the churn. Churn is coming from the demographic. So I would like to join this table with demographic. Account is A, demographic is D, and they should be matched based on a customer ID. This is D and this is account. Customer ID is coming from account, tenure is coming from account, balance, this, and the last one is the churn. Churn is coming from the demographic. If I run this specific section, we have a list of the customers that managers need. But it's not parameterized. They are seeing the whole list of the customers. They would like to have the dynamically change the data. So we need to say where. Now we can apply the condition. What is the parameters? These are parameters. So I can say where the tenure should be something and balance should be something and the number of the product should be something. For example, let's say if the balance is less than, and number of the product is less than, and tenure is more than. These are the conditions for this specific. For example, managers want to see list that we have, the list of the churned people who are the tenure is more than one specific number, balance is less than a specific number, and number of the product is less than a specific number. Here, now we should define our parameters. Okay, I said tenure should be minimum tenure. For balance, I say maximum balance. And number of the product is maximum product. These are what I define. I can change it to whatever I want, but I need to define it. So I copy all of them and go here and paste it. I don't need the rest. I only need the name. Okay. I would like to define here. Okay, I can say declare this specific function. And based on a data model, the tenor should be integer. So it should be integer. And what is the default number? The default number for tenor, for example, is 2. This is the minimum. Why? Because we said the tenor, it should be more than something. Or right now, the default number is 0. It means the default number for application is 2. Now, what about the next one? The next one is, again, I would like to say declare the max balance. The balance is decimal. So I can say decimal. And it should be, for example, 30,000. This is the maximum. However, maximum should be more than. This is 70,000. And the last one is again declare. Oh, it should be @, not hashtag. Okay. And max product is again integer. And max product, I would like to have, this is the maximum number of the product. So we should put the high number. I put 7. It might be less than, but it shouldn't be more than 7. Now I remove the rest. Let me just, okay. This is our formula. We defined our parameters, and this is our code. This is the filter that we have. If I select it and run it, we couldn't see any customer that tenor is less than 2. For example, if I put the tenor as 8, let's see what is the result. All the tenors are 10, 9, or something. And I would like to change it. Maximum balance is 100,000. We have these number of the people. Or the maximum product is only 3. Let's run it. You see, the managers have so flexibility to work on a data. Whatever they added in that application, they can just simply filter the data. This is very high number. Put it down, for example, for 9, and maximum product is, for example, 6. We have only this number. This is very, very useful when you want to parameterize and make your process dynamically. After that, you can pass this code to the software developers team, and they can make that beautiful application for the managers. Okay, this was the exploratory data analysis phase for our project. Now we have good understanding about the tenor. We know what is the churn rate between the age categories in different sections. But we need to do something as a statistical things because we need to have some more details and in-depth information about the relationship between the data and how they impact on each other, which is the section that statistical testing comes to play. And this is the next phase of our project. All right, let's start statistical analysis for our end-to-end data science project. In this section, we are going to go in depth for our project. We know that there are several statistical tests, but we don't want to use all of them. Before doing any statistical testing, we should know, based on the goal and objective of our project, which kind of test we can use. For this particular project, we are going to use 3 kinds of tests. The first test, let me just bring it. The first test is t-test for testing independency. This is the first test that we are going to do. The second test is chi-square. And the third test is ANOVA test. Each of them is designed for a specific target and objective of our project. T-sample test is for checking one numerical column with one binary column. And what we are going to test? We are going to test whether there is a difference between the average of the balance amount between the people who churned and not churned. So for this specific test, we have two things. We have one of them. One variable is categorical, which is churn or not. And the other variable is, let me just put it there. The other variable is numerical, which is balance, or the amount of the balance that a customer has. These are our variable for this particular test. And we want to see whether the average of the balance amount for the churned people and not churned people is the same or not. Why we are going to test that? Because in the banking industry, the amount of the balance that you have might be a driver for you to make a decision. You want to leave the bank or not. This is the first test. Before talking about the chi-square, let me talk about the ANOVA test, because the concept is almost the same with t-sample test. But here the difference is that we want to see one numerical variable and one categorical, but that categorical should be more than one label. So we can't use churn. For this particular test, we want to see the average tenure between the customers for different countries is the same or not. So categorical, as I said, should be multi-label. So it should be location, because as you know, we have 6 different locations. And we want to see the average of the tenure between different locations is the same or not. You see here we have numerical and categorical. And here also we have numerical and categorical. But here we use t-test just because we have binary churned or not. But here categorical is multiple. We have more than 2 labels. So we need to use ANOVA test. And chi-square, let me just copy. Chi-square is categorical and categorical. So we want to see, for example, is there any association between, for example, the churned people and is active or not. Chi-square test is not checking the differences between the mean, because both of them are categorical. We are checking the association. Here, we want to see, is there any specific association between the churned customer and their account status? For example, maybe if the account status is open, the less number of the customers want to churn, or vice versa. So these are very important drivers for this specific project. Now I'm going to show you every single of these tests. But before going to my notebook, I would like to say, after checking all of them, we just see the result. For example, here we only see, okay, the differences between the same or not. Or here we can see the differences between the locations is the same or not. And here we can test whether there is association or not. But this is just a test. We need to find the effect size. Effect size is very important when we want to apply statistical testing on a business perspective. Because let's assume that, for example, here we said there is a difference between the balance scorecard for those people churned and not churned. This is what t-test tells us. But effect size goes a step further, and it tells us how big this impact or how big this difference is. For example, if the difference is $100, it's not totally important. Whereas in contrast, if the difference is $1 million, it's a totally different story. So we need to do effective tests for each of them. So effective test, each of them has its own effective test, and we would like to do also those tests. For example, the effective test for t-sample test is called Cohen test. The effective test for ANOVA is called Omega and ETA. And the effective test for chi-square test is called Kramer. Kramer test. These are the tests that we would like to apply after each of them to make sure whether those difference or those interpretation is important or not. Now we can go to my notebook and project to see what we can find from the different tests. Now you can see the left side, we have our project, structure, and categories. There is a folder which is called statistical testing. Inside this folder, I have a notebook that you can see on my screen, which is called a statistical testing. And it's not the Python script, it's a notebook, Jupyter notebook. Why I use notebooks? Because for some kind of statistical testing, we need some explanation. We need to document all the informations and output that we have. And that's why we didn't use a script. For the data cleaning and data pre-processing, we use a script because in that particular phases, we just want to apply the logic for data cleaning, data pre-processing, and whatever. But here we need to explain about our results. And that's why I use the notebook. First of all, I install the libraries that I need. I import the Python or database connection because we need to connect the Python with the SQL Server. You know that in the previous phase, we ingest data to the database, we do some exploratory data analysis, and now the data is stored there. We don't have access to the real data here, so we need to make a connection between Python and the SQL Server. We need pandas and we need NumPy and we need SciPy also because we need to do some statistical testing. After that, you're familiar with this piece of code. This is the code that makes a connection between the Python and SQL Server. For example, for drivers and for the server, this is my server and the name of the database. And after that, we create a cursor, which is doing the connection between Python and SQL Server. Now we can go for do all the testing that we have it here. We can start with independent sample test. This is the t-test. In the sample test, the first thing is that we should know what we are looking for this specific test. For this test, we are looking for to answer this question. Do customers who leave the bank or churn differ in account balance compared to loyal customers or not? Simplified is that, is there any difference between the average for the account balance in churned customer or not? But why this question is very important for banking managers? Because if we answer this question, the answer directly influences several strategic decisions, such as the bank can run some retention campaign targeting. They can apply some VIP programs to retain the customers. They can segment the risk and they can forecast their revenue. These are very important. And if we say, for example, the high balance customers, the customers having the high amount of the balance are more prone to churn, in that case, the bank should apply some strategies and take some actions to try to protect that customers. And if the low balance customer churn more frequently, they have to apply different strategies to engage the customers to retain in the bank and not churn. This is the first one, the business question. Now we can go to a statistical hypothesis. Before doing any statistical testing, we might have some hypothesis. Otherwise, applying any test doesn't make sense at all. So we aim to compare the average account balance between two customer groups. The customers who have been churned and the customers who have been retained, or we call them loyal customers. So the null hypothesis is that the mean or the average account balance is equal between these two groups. This is a null hypothesis. And the alternate hypothesis is that the mean or the average account balance is different between these two groups. We would like to test to see which of them we can reject and accept the other one based on the t-test. So which kind of columns or data we need for this particular t-test? As you know, the t-test needs one numerical column as a dependent and one categorical or binary column as just two labels as independent. The balance amount represents the continuous numerical, which is great for our test, And churned define two customers, churned or not, which is our binary categorical code. Let's talk about the test assumption. Before doing the t-test, we should meet the simple assumption for these tests. Otherwise, maybe we can't use this test. Let's see what is the test assumption for t-test. The first one is independency. Just because the observation that we have for this banking record, all of them represent one customer, is a unique record. So the observations, all of them are independent. So this assumption is totally satisfied for our project. About the normality. T-test, you know that. T-test is a kind of t-distribution, and t-distribution should be normal distribution. And in this case, just because we have more than 30 records per each group, we are definitely following the normal distribution with thanks of the central limit theorem. So we don't need to be worried about the normality. About the homogeneity of variance means the variance of the balance should be equal between the group churn and loyal customers. We will test it. If the variance is not the same, we can't use t-test. We should use village t-test. This is another t-test, but it is only useful when the variance is not the same. How we can test the variance? Based on a Levin test. Now let's see why we are going to use t-test or even the village test. Because we are having one dependent variable as a continuous numeric, which is a balanced amount or not, and the independent variable is a binary categorical. We have the churn. And the objective is comparing the group's mean. So it is totally the best situation for using the t-test. Now let's go for implementing the test and running the test. We have 5 sections, and we would like to go one by one. The first one is that data preparation. We need to extract data from the SQL Server. And just because now we have cursor and connection, we only need to write down the query inside the quotation and after that grab the data. It means if I put the SQL query inside the quotation and after that pass that query along with that SQL connection, I can find the data. For example, right now, if I just create one test SQL, and here I copy this SQL code. The connection is applied for my work because this is the SQL Server and this is my database. And this is the SQL environment instead of going with Microsoft SQL Server. Right now, even I can run the code for SQL. I would like to grab the data from the account. If you remember the ERD, the amount of the balance is stored in account table. And the churned or not is stored in demographic. And what is the common key between them is the customer ID. If I run this code, you can see the data is here. And instead of even writing in SQL Server, I can work with SQL here because this is the VS Code, and VS Code has so many flexibility for working with different languages. But how can I pass this code to the pandas or Python? I should put that code inside the quotation, and after that, pass that code based on the connection. And this is the data frame that I have. I just showed the first 5 rows as a head. Okay, the data is ready, and we should split the data. Why? Because we need 2 groups. One of them is for churn. Is 1 means those customers churn, and one of them is 0 means those customers are loyal. And we need to only grab the balance because right now we only need the continuous data. One group is for continuous or the balance amount for churned people, and one of them is the balance amount for not churned people. And I store those as a churned t-test and retain t-test variable. Now we should find the mean or average each of them. For example, right now we see the average balance amount for churned people is almost 102,000 something. And for retain is 119,000 something. Right now we can see the average balance amount for churned people is more than retained people. We can simply come back to our hypothesis test and say, okay, just because the churn mean is not same as the retain and it is the higher, so they are not the same. So let's go and reject the null hypothesis and accept the alternate. No, this is wrong, because it is just a simple comparison. We need to make sure whether this difference is by chance or really there is a significant meaning behind this difference. If this difference is by chance, we can say, okay, this is by chance, so they are the same. And if the null hypothesis is rejected, we should accept the alternate and say, yes, the churn rate is more, and this is a significant difference. We can accept this difference. So before going that, if you remember the assumption, we need to make sure about the equality in a variance. So I applied the Levene test for the churn people and not churn people. And you can see the p-value is pretty close to 0. And just because the p-value is less than 0.05, the null hypothesis for Levene test is rejected. It means the variance are not equal. In Levene test, the null hypothesis is the variance are equal, and the alternate hypothesis is that the variance are not equal. Right now, just because the null hypothesis is rejected, we can say the variance is not the same. And just because the variance is not the same, instead of using t-test, we should use Welch t-test. Now we know our data, we know which kind of test we can apply. Let's apply the test. I applied the t-test, and here I should say equal variance is false. If I put that, the stat library in Python understands it's time to use Welch test instead of the t-test. And you can see the p-value for the result is 0.17, which is much higher than 0.05. So we can interpret, just because the p-value is more than 0.05, we cannot reject the null hypothesis. So it means there is no difference between the balance amount for churned and returned people. It means even though the average for the balance for churned people is more than retained people, this difference is totally by chance. And maybe in the next time, if we run with the different sample of the people, we get the difference data. We get the difference result. So it means the difference is not very important. So we can say that average mean is totally the same. But again, this is what the tests tell us. After that, we should analyze the impact of this test. Okay, now we can go to chi-square test. Chi-square test, again, let's see what is the business question. Let me just close it to have better space, and I can even close this. Okay. The business question is, we are looking for to answer this question. Are inactive customer or the inactive account more likely to churn or not? To simplify it, means we want to see churning the customer is associated with having an active account or not. We have two categorical columns, and we need to apply chi-square t-test. One of them is active or not, and the other one is churned or not. But why this question and this objective is important for managers? Because if the dependency exists, if the closed account are more likely to churn, the insight can directly support some strategic decisions. For example, we can send the early warning to the customers to make sure right now, for example, if they close the account, right now we can send some notification to the system. Today, one customer closed the account. So just because there is association between the closing account and churning, we start to apply some campaigns and initiatives to try to convince the customer to stay in at the bank, or other different initiatives. So this is very important for managers. About the statistical hypothesis, again, what is the hypothesis? The hypothesis is churn and customer activity, or the is active or not, are independent. It means they are not related to each other. This is a null hypothesis. An alternate hypothesis is that those variables are totally associated with each other and they are dependent to each other. Which kind of columns that we need? Definitely we need isActive column, which comes from the account table, and Churn column, which comes from the demographic table. For chi-square test, just because we have two categorical data, we need to have contingency table or crosstab table. And it shows just the frequency across the different categories. Like the other test, chi-square test has its own test assumption. The first assumption is that variables are categorical. And as you know, both of them are categorical, so this assumption is met. The other one is independence of observation. Each observation must be independent, and as you know, in the banking dataset that we have, each customer represents a unique record, so this observation also holds. And the last assumption is expected frequency. It is about the contingency table. And for each cell, each crosstab between different categories, at least they must have 5 records. And this is the minimum requirement for contingency table. Later, we can see and check this assumption. Now let's answer why we would like to use these tests. Based on what we're looking for, we can choose we should use chi-square test or not. The objection is association. We would like to see whether there is a relationship or not. The dependent variable and independent variable, both of them are categorical. And this is the best scenario for using the chi-square test. Now let's go to the implementation. The first step is again the data preparation, and again I put the SQL query inside the quotation. And as you know, one column is churn coming from the demographic, and isActive is coming from the account. So we need to have a join table as a SQL query and put it there. After that, I pass that query along with the connection. So this is just our data. At the first type 5 rows, you see we have one column churn, one column is isActive. So data is ready to proceed. The next one is we need to build the contingency table. The contingency table, the pandas data frame has a method which is called crosstab. I pass the churned column and isActive column. You see, we have the crosstab here. For example, we have 3,547 people, they didn't churn and they closed the account. And we have 4,416 records or 16 customers. They didn't churn and the account is still active. And the same interpretation for the other record. Now it's time to run and implement the chi-square test. I would like to have 4 different outputs from the test. One is the chi2 or chi-square. The other one, which is the most important one, is the p-value, the degree of freedom, and the expected. I use the expected because for the effect size, for checking how big the impact is, I need the expected. So I capture 4 records, and you can see the p-value is pretty small. It's almost 0. So based on this, we should also check the frequency. Each record, if you remember, one assumption is they must at least 5 at each cell. You see, we met this assumption also. Based on the p-value, just because p-value is less than 0.05, it means we reject the null hypothesis. What is the null hypothesis? The null hypothesis, if I go up, you see churn and customer activity are independent. But just because we reject it, we should say churn and customer activity are totally dependent to each other. So now this is a good hint for managers. If one customer close the account, this is a good hint for them that this client might churn in future. Okay, let's move on to the last test, which is ANOVA test. What is the business question for this particular test? For this test, we are going to answer this question. Does customer tenure differ significantly across countries or not? Again, we are going to check the average mean for one continuous column or numerical column, which is tenure, with one categorical column. But this time, that categorical column is not binary, like churn or not. This is one category have more than 2 labels, like countries. As you know, we have 6 different countries, and each of them has its own category. But why this question is important? Because if tenor is lower in certain countries, it might show something. It might show customers in those markets, in that country, maybe are more willing to leave earlier or maintain shorter relationship with the bank. Or customer acquisition or attrition dynamics differs by market, and maybe different countries have different patterns. So they are very important for managers, and they should answer these particular questions based on these tests, and this is very helpful for them. What about the statistical hypothesis? We have 2 hypotheses again. Null hypothesis is the average of tenor is all countries are the same. I have a spelling error, let me check it. Countries are the same. And the alternate hypothesis is that the average of tenor for all countries is not the same. One of them is the same, the other one is not the same. Which kind of column that we need? We need tenor as just a numerical column or variable for this particular test. And we need geography. Do you remember the location table in our database? Geography is showing the location for the country. Like the other test, we have test assumptions here. We have 4 different assumptions. The other one is independency. And as you know, each customer in our database is just one record. So this assumption is met because we have independent data. We need to make sure about normality within each group because the distribution of the tenor might not follow the normal distribution. If it's not, we should use the other test. But right now, just because we have a lot of data, an ANOVA test usually is very robust to non-normal distribution. So we don't need to worry about this assumption. Homogeneity of the variance, like the other test, we need to make sure the variance for the tenor, which is the numerical column, should be similar. If it's not, instead of the ANOVA test, we should use Welch ANOVA test, like the t-test that we used, Welch t-test. And the sample size per group, we should have the adequate number. Just because we have a lot of data, we don't need to worry about these assumptions. But now let's answer this question, why we are going to use these tests. Because the objective is average mean, so here we can use t-test and ANOVA test. Dependent variable is numerical, again we can use ANOVA test and t-test. And the game changer is here, the independent variable is multi-categorical. And this is why, instead of t-test, we should use ANOVA test. About the data preparation, what kind of data we needed? We need the geography, and we need the tenor. This is the query that I wrote, and this is the data that we have. We have tenor for each country. And this is just the first top 5 rows. About the descriptive stats, we should find based on a group by. We need to group data. Unlikely the t-test, we couldn't simply just split the data and find the mean, because here we have 5 or 6 different categories. So I group data, and after that, for each of them, I find the count or number of the records. I find the standard deviation and the average. You see, for example, UK has 1,703 customers. The average of the tenor is almost 5 years, and the standard deviation is 2 years. For France, it's almost the same as US, but for Germany, Canada, and Spain, the tenor is almost 4 years, almost 4 near to 5 years. These are just the basic descriptive for ANOVA test. Okay, now we should check the variance equality, which is one assumption for the test. I use the Levin test and apply the Levin test on a standard deviation for each categories that we have, and you can see the p-value is pretty big. It is much more than 0.05, so null value, I should say it should be rejected. So the variance are not equal. So instead of the ANOVA test, we should use Welch ANOVA test. So I run the test, and you can see the p-value is 0.46, which is more than 0.05. And the interpretation is that just because the p-value for Welch ANOVA test is greater than 0.05, it means we fail to reject the null hypothesis. So we should accept the null hypothesis just because the average of the tenor is all countries are the same. If I come back to the null hypothesis is here. We cannot reject it. Why? Because p-value is so big. So we can say the average of tenor in all countries are the same. So this is the ANOVA test, and we apply the ANOVA test, t-test, and chi-square test. But it's time to talk about the effect size, which is very important, as I told you, when we want to apply statistical testing on a business concept. Okay, the effect size. Right now, let's just recap what we did. We did the Welch t-test, and the result was no significant balance, mean difference between the churned and retained customer. It means the average is totally the same. Chi-square said there is a significant association between the active account and churned customer. And the ANOVA test said, okay, the tenor mean between the countries is almost the same. But we need to test it. Let's start with the t-test. As I said, for t-test, we should use Cohen test for checking the effect size. Cohen test has a table, as a standard table for the effect size. If the result is 0.2, we can say the effect size is very small. If it is 0.5, this is medium, 0.8, this is large, and more than 1.2, this is very large effect. I apply the Cohen test. I don't want to go into details of the code because there is a formula for Cohen test. You can search it on the internet. I just mimic the process, just calculate the number of the sample size, the standard deviation, and mean. And after that, I calculate the pooled standard deviation and find and calculate the Cohen test. You see the Cohen D, or the score, is 0.03. 0.03 is less than 0.02. So it means the effect size is pretty small. So what is the result for this effect size? We say the p-value is so high for t-test that we saw in the previous section, and said that the difference balance amount between the churn and retain is not important. So it means they are the same. And a small Cohen number said even if there is a significant difference, right now there is not, but it said if even there is a significant difference, from the business perspective, it was negligible. It wasn't important. So it means the effect size confirms our test that for t-test. What about the chi-square? Chi-square, we should use Kramer. And Kramer, based on standard, has some effect size. For example, 0.1 is so weak association, 0.3 is moderate association, and 0.5 is very strong association. I apply the formula for Kramer, and the score for Kramer is 0.15. 0.15 is between weak and moderate, so we can say something is between this one. So this is the result. Based on a chi-square test that we did it before, the small p-value says there is a significant difference between the active account and the churn people. It means whether a customer is active, they are more prone to retain and vice versa. But the moderate Kramer score said that this association is weak. It means even though there is association, we cannot rely on it too much. And it's not the only driver factor. And it is very good for managers, just because there is association between the churn customer and having the active account or not. It's not the only driver. It is moderate, and it is very, very weak Kramer score, so we cannot rely on it too much. And the last one is ANOVA. For ANOVA, we should use ETA or omega test. And there is a score. You can see we have small, medium, and large. This is a bit more different with the other. For example, first of all, we should calculate the SS, or sum of square. For this number, we have, this is for just a score. For SS total, we have 83,000 something. And we need to right now, based on that score, we can calculate ETA. The score, you see, it is pretty close. And for omega, it is almost 0. So based on this, we are here in this section. And we can say the p-value for ANOVA test was so high. And it showed us There is no statistical difference between the average tenor across countries, and it means the average tenor in every single country is the same. But the omega test says that even if there is a difference, right now there is not, but even there is a difference, that difference is negligible. So we can say average tenor between the different countries is almost the same. Do you remember that table for ANOVA test? I said for Canada is almost 4, for UK is 5. They were different, but the test confirms that even there is a test, that test is so negligible, so we can say there is no difference. In this phase of our end-to-end data science project, we applied as a data scientist and applied different statistical testing to make sure what is the impact of every different columns and variables for our target. And this is a very good step before going to the machine learning section, because now we know the relationship between the data and how they impact each other. Now we are ready to go to the machine learning section and build a model for churn prediction. All right, let's continue our project in machine learning phase. In our end-to-end data science project, one of the most important and challenging parts is machine learning, or making a predictive model for our objective. The objective of our project is just making a model for managers to help them find the churner or the customers who want to churn from the bank. So in this particular phase, we are going to build that model. But please note, we are not going to deploy the model for this particular project, because deploying the model is beyond the scope of this project. We only need to do some experiments to build the model. After that, if we are working as a data science team, we should pass, as a data scientist, we should pass this model to ML engineer or machine learning engineer team or DevOps team. They are going to deploy the model. We are just going to experiment different models to find the best one based on our project requirements. All right, you see we have the predictive modeling folder. Inside it, we have 2 folders. One of them is for process data. We are going to see how we deal with the data to process and make it ready for machine learning objective. As you know, the models or the algorithms understands the data only in a specific way. And the other folder is for experiments or building the model. In the first step, we should go and see how data should be ready or pre-processed for our project. So inside the process, you see there is a pre-processed script. If I open this file, the file is here, and there are some steps that I'm going to walk through all of them to make sure we cover all these sections. All right, in the first step, we should import the packages and the libraries that we need for this particular scripts. We need NumPy and Pandas because we are working with some numerical and tabular data. We need PyODBC to connect to our database, like the way that we did for previous sections. We need scikit-learn for just standardize the numerical data. And we need joblib for save the clean and pre-processed data at the final stage. I select all of them and just press Shift and Enter to import everything. In the next step, we need to connect to the SQL Server and pull the data that we need. First of all, I create a connection between my SQL Server and the database at the bank Churn. After creating the cursor, I'm ready to pull the data from the database. Based on our objective for our project, here I only need some specific information. I need gender, age, salary, and geography. I also need the tenor, balance, number of the product, whether the account is active or not, and the credit card. And the last one, I need a target, which is churn. I need data from demographic, then I joined it with account table and the location table. This is a query, I put all of them in a quotation, and after that, I convert all of them to a data frame. If I select all this step and run it, Now we can take a look at the data frame. I select the data frame and run it. This is exactly the data frame that we need for building the machine learning. We have all the data that we have. Each of them is coming from different tables, but just because we concatenate all together as a SQL query, we have one table. This is the magic for working with the SQL Server and Python as an isolated and modular way. Okay, we are ready to split the train and test data. Before do any pre-processing, like as a one-hot encoding or scaling or even feature engineering, anything, we should split our data to 2 different data sets or 3 different data sets based on our object. For example, we can split to train, test, and evaluation, but for this project, I only split it to train and test. I put fraction as 80%, means 80% of our data is being used for training and the rest for test. And the seed is just a random seed for starting the way for finding the sample records. I define a training data set and I use the sample method. The fraction, I put our fraction, and the random seed, I put the defined seed. And after that, the test data set is everything from the data frame except those indexes related to the data frame for training. For example, right now, if I just select and define the training, if I select the training, we have 8,000 records. That's because total records is 10,000, 80% is for training. These are all indexes. You see here, all of them is for training. And I say, for the data frame that we have, exclude all the indexes related to data frame train, and the rest is for data frame as a test. If I run this code, you see the rest, all of them is for test. We have 2,000 records. Now, if I select the df train and df test lengths, you see the 80% or 8,000 is for train and 2,000 for test dataset. We just simply split train and test dataset. From now on, we are only going to work on training dataset. Why? Because at the same time, if we work on a test dataset, it might lead to data leakage. Okay, so let me clear the reports and now we can continue. Okay, in the next step, if you remember the statistical phase that we did some statistical testing on the data, and we know that there is a good relationship between some variables. So based on those information, we can create 2 or more columns, because these columns or these features bring a lot of information for our project. For example, the first one, I'm going to create a ratio, which is the balance divided by the salary. And it gives me as a one new feature as a balance salary ratio. And the next one, I would like to make a ratio for tenure and age. It is just tenure by age. If, for example, I select this piece and I run it, these are all the data. I divided the balance by salary. So I would like to store all of them as one feature. And the next one, I run this code. Now, if I select the data frame only for train, you see if I go all the way to the right, we have 2 new columns. One of them is balance divided by salary, and the other one is tenure divided by age. They are very helpful for our project. And as you noticed, for this section, we didn't do anything about data cleaning, missing values, or anything. Because if you remember our initial phase for our end-to-end data science project, we did all those steps. And just because we extract data from the database, we are pretty sure we don't have any null value. We are pretty sure about the data type and these kind of data wrangling. Okay, the next step is that if you see right now, we have some numerical columns. For example, we have salary, we have age, we have tenure, we have balance, number of the product, and those new columns that we created. So we need to scale them. We need to make sure they are on the same scaling. So if I select only the columns that are integer or float, if I run it, these are the columns that are integer and float. You see, if I select the data frame and just scroll up, okay, you see, we only selected some specific columns, not all of them. We only selected age, salary, tenor. We didn't select geography, balance, number of the product. If I go a bit to the right, balance, salary, ratio. We didn't select even have a credit card, is active, and churn because they are not integer or float. You see here, we only said we need integer and float. So I pass all this code as a num columns or numerical columns. And after that, I just initiate the standard scaler. Now I can apply the standard scaler on the data frame training for which column? For those columns, they are numerical columns. If I run this piece of code and now take a look at the DF data frame, you see right now, for numerical columns, we have scaled data only for trained data set. But gender, geography, and those binary columns has credit card, is active, and churn. They are untouched. Why? Because they are categorical, and even one of them is our target. We don't need to touch it. Okay, here we need to do the same process, but only for the columns. They are Boolean, like if I go to the right, like has a credit or is active. A string or object. A string we have geography and gender. An object we don't have it, but just being in a save, I added. But we need to exclude one column, which is churn. Why? Because churn is some kind of Boolean that we needed, but we don't need that specific Boolean. We only need has a credit and is active as a Boolean. So I select this piece of code. Now we have a new columns or new list as a categorical column. And then I say for each of those columns and for each unique values they have, just put as a NumPy mapping. For example, if we have like a gender, if I go all the way to the right, for gender, the unique values we have male and female. As we know for the initial steps and previous steps or the data documentations. This is why I said we should always come back to data documentation and check it. We have two values. For each, just map based on a value 1 or 0. If the rows has that specific one, put 1, otherwise put 0. And you can do for geography, we have 6, so we need 6 columns. For gender, we need to have 2 columns. And even for the Boolean, we need 2 columns, 1 for true, 1 for false. And after that, the database is created, remove the initial columns. If I run this piece of code, and if I select the data frame, just open a bit, you see we have if I go a bit up and go to, you see, for gender, we don't have it right now. Why? Because we said we should remove it. But if I go to the right, for gender right now, we have 2 columns, gender male and gender female. And also for geography, we have USA, we have UK, Spain, Germany, and all the countries. Also for those Booleans, has a credit card, false and true, and is active, false and true. But churned, we didn't touch it because this is our target. Okay, let me clear and go to the next step. In the next step, we need to do all these steps from data engineering, scaling, and encoding for testing data. I created a function as a data frame test pipeline. First of all, I'm going to add 2 features. After that, I transform the scaling. I didn't fit here because if I put the fit, I see data leakage. I only transform data set for the test. And after that, I apply the one-hot encoding and then return the DF for the testing. If I run all this piece of code, you see right now, the test data set is exactly as we want. Churn, no change, and the rest, we have 1 or 0. Okay, this is very important section. Just because the test data set might not have the same order as the columns as a training data set, we should make sure the training data set and test data set have the order of the column as the same order. So I say for df train columns, if this is equal with the test data set, show me true. Otherwise, show me false. If I run it, we see false. Means the columns for training are not in the equal order with the test. So how we can make them order? We only need to reorder the test data set. And we need to set the test data set should be ordered based on a training column. So if I run it, now if I again run the equal, right now they are in equal order. The next step, we pre-process data, we scaled and we encoded, and even we ordered all the columns. But we need to exclude or create a new column as a target. We need to separate or declare features and target. The features are all the columns except churn, and the target is only the churned column in both training dataset and test dataset. If I select everything, you see right now, for example, target for training and features for training and features for test and target for test. Now we have everything. We have all the process, all the data that we needed. I need to store, I only need to clear. I need to store or save these data sets as a one bundle pickle file. Because later, if we want to apply different experiments or different models, we don't need to run the data again or save as a CSV file, because CSV file is super slow when we are working with machine learning. I bundled all this data set as a pickle file, and whenever I need it, I only call them. Where I would like to store them, if I go there, you see I would like to store here. If I run this piece of code, all the data is here at the data set bundle, and inside this bundle I have 4 different data, and whatever I want I can call from that bundle. Now the pre-process is done. We have 4 different data sets and we are ready to build different algorithms to see which of them is working on our data better. Okay, now it's time to start working on different experiments. I can open the experiment folder, and before going to those notebooks, they are some experiment, different models, I prefer to first start with the structure of this folder. As you can see, we have one init or initiation Python. Why? Because I have one script and I would like to call that script whenever I want. For example, if I open the evaluation script, this is some kind of script that I wrote it here. It means in those notebooks, in one stage, we need to evaluate the model. But I don't like to run this code over and over again. I don't like to copy and paste this code in my old notebooks. The structure is the same for every single model. So I better to store these function as a separate script. And whenever I need it, I only need to call this specific function from my notebook. But for calling or this connection between a script and notebook, I need the initiation Python. That's why I have those 2 Python scripts here. And this function is a very simple function. It just needs the model and the test dataset, and it just brings back some metrics for our specific project and the models. It's just applying the machine learning model on a test dataset and brings back the metrics. Okay, I start with the easiest or the simplest algorithm, which is logistic regression. The structure of all these experiments are the same, and this is something should be, because we are running different experiments, and each experiment might have different run. If I wanted to work on some cloud environment like Vertex AI for Google or Azure ML in Microsoft, this is the process exactly we do. But here, just because we are not using MLflow, we need to track and check the metrics manually. But if we wanted to work on a cloud, we need to have different experiments, but we don't need to check the metrics manually because their MLflow library, which helps us too much. But also it needs some compute resources and some money for working on a cloud environment. All right, Let's start with logistic regression. First of all, I need to load the libraries and the packages. You're familiar with all of them. I first start the job lib because I need to load the data that we stored in the previous sections. I need to import the grid search for doing some hyperparameter tunings. I need logistic regression definitely, and I need that evaluation function from the script. The name of the file is evaluation script, and inside that file, I need that function. These are the library. After that, I load those bundled files from the process dataset. I create 4 objects and assign each dataset, train and test, each of them feature and target to different objects. Now I have our training, our test for features and for targets. We don't need to do all the pre-processing here. We did it and we here, and here we just call it. In the next step, I define the parameters grid or I declare the parameters. This step might vary based on different algorithms. Right now, we are working on logistic regression, and these parameters are most important for logistic regressions. And as you can see, all these parameters, all of them are discrete. And I didn't use continuous here because it takes a lot of time, because I'm going to work on a grid search. Then I create the search space. I put some argument for grid search function. First of all, I declare the algorithms that I'm going to work. This is the logistic regression. I put solver, and the class weight I put balance. This is very important. Why? Because our data set is in balance. It makes sense. Most of the customers in our data set that we have, they didn't churn. But we are looking to help managers to find those are churned. So we are looking for the minority class. So we should let logistic algorithms know that the class weight for datasets should be balanced. In this case, the algorithms put some weights based on a different label that we have in target. Then we assign the parameters grid that we just saved it in the previous cell. Cross-validation, I put 10. 10 is good for logistic regression because logistic is a fast algorithm and it's making sense. Refit, I put true, just fit the data automatically. The scoring, I put F1 score and no accuracy. Why not accuracy? Because accuracy doesn't work for imbalanced dataset. F1 score, which is just a hyper average for recall and precision. And verbose, I put 0 because I don't like to see the process as a visual. Now, I saved all of them as just a model. This is our model for running. I fit that model on train features and train targets. And after that, just because it is coming from the different combination of the hyperparameters, I said get the best estimator based on the F1 score. For example, this model is gonna make a combination so many times. This is a grid search. It's gonna apply based on every single different combination. And finally, each of these combinations having the highest F1 score gives me as the best model. After running, you see the logistic regression. These are the best combination. The penalty should be L2. We have different parameters. Some of them are specifically default for the logistic regression. L2 regularization is the best one, and L2 is very good when we have so many different columns, and it doesn't remove the columns. It shrink the columns to 0, but it didn't remove that column. But L1 totally might remove the column. And all the combinations, and you can see the class weight here is balance, which is very important. Right now, we have the best model, and we need to apply that best model on test and training. Here, I use that function that we created in a script. I only need to call that function and pass the model. You remember that script needs 3 arguments. If I come back, we need the model, we need a test for feature and for a target here. The model is the best model that we save it here, and test for feature and target. And as you can see, the recall churn is 65%. For this project, recall is the most important factor. But why recall? Why not precision? we are pretty sure that we shouldn't focus on accuracy because we have imbalanced data set. But why recall? Let me explain like this way. Okay, let's say we have actual data and we have predicted by model. For each of them, we might have, for example, not churn or 0, and this is, just give me a space, not churn and churn or 1. This is some kind of very simple confusion matrix that I created here. Just make it a bit better. Okay, here and there. Okay. As you can see, we can have 4 different combinations. We might have one section here. We might have one section here, here, and here. I'm explaining why F1 score is very important for our project. Let's say the actual data says for the test data set, it says the customers didn't churn. And also the model predicted that customer didn't churn. So this is true, negative. And let's say the customer didn't churn, but the model predicted that customer churned. So it is false positive. And the other way is that the customer churned, but model said the customer didn't churn. So this is false negative. And the last one is customer churned and model predicted churn, true positive. You can see 2 of them are pretty good because they are exactly what they should be. One of them is this one, true negative, and true positive. They are exactly what they should be because the customer didn't churn, model said no churn, and the customer churned, model said churn. That is perfect. But we have 2 bad things here. Based on a specific object for each project, we should make sure which of them is more important. But before doing that, let me explain the formula for recall and precision. Okay, the formula for recall is, just put it here, recall is true positive divided by true positive plus false negative. This is for recall. And the other one is for precision. True positive divided by true positive plus false positive. You can see each of them has its own. Just make it the red to make sure we are targeting that specific errors. You see, each of them contains one error. But based on the objective of our project, we should say which of them is very important. I know F1 score is just a combination of them. It is important. This is our metric. But it is the second metric for evaluation that which model is important. The first one is between recall or precision. For making decision which of them is important, let's say I'm a manager of the bank. And I ask the model to let me know whether this client is churned or not. Let's start with this section, precision. The model said, yes, this client is churned. So just because model said churn, I as a manager start some campaigns and try to convince the customer to stay or give her some accounts or discounts. This is very good for customers and they are happy. That's very important. even if, in fact, the customer doesn't want to churn. In fact, model said churn, but customer received some services and even she didn't want to churn. So it means this kind of error doesn't hurt because we just give some more services to the customers who doesn't want to churn. That's fine. But the other way around is very dangerous. The other way around is recall. And it said, model said, no, this customer is not going to churn. So that's because the model said no churn. I don't do anything for that customer. I don't run any campaign. I don't run any action for convincing the customers to stay. But in fact, the customer will churn. And we lose our customers just because the model told us this customer is not going to churn. This is very dangerous for bank. So for bank, reducing or decreasing the F1 score is very, very important. In which formula we should decrease the F1 score? It is exactly here. So if we decrease the F1 score, means we are increasing the recall. So now we made a decision. Which model is the best model? The model that recall is higher. Any model in any experiments that we are running, any of them, has the highest recall. This is our selective model. Now we know that which metric we are going to select. Let's come back to the experiment. All right, the logistic regression, the recall is 65%. That's fine. Let's see what about the other model. The other model is random forest. For random forest, I don't want to explain the code. They are exactly the same, but I used its own parameters. Again, the class weight is balanced. The cross-validation, this time I put 5 because if I wanted to put 10, it takes a lot of time. The parameters based on the best model is this parameter, and I apply that best model on the test features and target. You see, the random forest is 63%. So far, the logistic regression works better than random forest. What about the next model? The next model is support vector machine, and it is based on a polynomial kernel. Again, all the process that I did, the parameters, the fit the models, and right now the recall is 67%. So, based on our model so far, the support vector machine as a polynomial kernel works as the best model for our specific project. Why? Because the recall is the highest one. What about another kind of support vector machine, which is for the RBF kernel? Previous one is for based on a polynomial. This is based on an RBF. The RBF has even the better recall. It is 71% recall. It means out of all churned customers, even they are the minority compared to the 0, 71% of them exactly the model could recognize. That is pretty good. However, there are a bunch of ways to improve the model, the performance. But in this project, we are just going to find the basic model or the baseline model. So far, the support vector machine RBF kernel is the best one. What about the XGBoost? For XGBoost, I selected, you see, 66% as a recall. So we just applied 5 different experiments, and you see that this one, the support vector machine with RBF kernel, is the best baseline model for this project. I would like to stop machine learning step here because after this step, the process is just iterating. In the real world scenario, the process is that, okay, right now I have my baseline model, but I need to improve it. I go to the database to select different databases. Maybe we have some financial more information that we didn't even think about it from the start of the project. We work with different teams. We bring some more data. We apply even different parameters, or even we apply different algorithms like deep learning even to try to improve the recall performance. This is some kind of iteration process. Whenever we are happy with the result, we pass this model to the ML engineer team to deploy the model. This is the process, but it depends on a company that you are working. Some companies, data scientists should deploy. In some big companies, the teams are well separated, and they can just take advantage of this condition. They can pass and iterate the process together. All right, in this step of our end-to-end data science project, we applied machine learning models based on the modular and product-based approach, because our code are super flexible and this is modularized. This is exactly designed based on a product base. It's not gonna working on notebook and try to do some different experimentation. This is exactly what it should be in a real world if you are not going to work on a cloud environment. These experimentations, the logic is the same, but the process might be different if you are going to work on a cloud environment. For example, in Azure, all the experiments can be handled based on MLflow, which is pretty important if you're going to work on a different experiment, different run, and each job that you're going to do. Okay, we are ready to go to the last stage of our project, which is data visualization. All right, let's do the last step of our end-to-end data science project. In this stage, I'm going to build very simple dashboard for our project. This dashboard might not be very sophisticated, but it covers whatever the stakeholder needs. The stakeholder for the dashboard needs some KPIs. One of them is that they need total number of the churned people, and they need total number of the customers. They also need the distribution of the churned people based on a country and based on the continent, because they have different locations. Also, they would like to see what is the distribution of the account status as an open account or closed account and churned people. In the statistical sections, we notice that these are two associated with each other based on chi-square test. Also, they need to see the distribution of the churned people and customer tenure, because it might help them to see how long the churned people or not churned people would like to stay in our bank. And the last thing is about the financial behavior. They would like to see the churned people in terms of the salary and in terms of the balance of the amount. What is the relationship between the churned people and just see is it some kind of the direct relationship or indirect as a scatter plot. Also, they would like to have some filters for the dashboard. This is a very simple dashboard, but it truly can complete our end-to-end data science project. So let's open the Tableau and start this stage. Okay, the first thing is that we should connect the Tableau to the database. As you know, our data is stored in Microsoft SQL Server, and even for machine learning and statistics, we use that data. So I go to Tableau, to the server, and select Microsoft SQL Server. When it opens, I should say, what is my server and database? If you remember in the previous sections, when we connected Python to the database via VS Code, the server is just Mehrdad, my name, and the database is bank Churn. The rest is default and I don't touch it. So I go for sign in. Let's wait. Yes, exactly. You see those tables inside the database is here. The account, demographic, and location. Okay, the next step is that based on the ERD that we have, we should create a data model. Tableau helps us to create a data model. But before doing that, let's take a look at the data. For account, if you remember this data, just let me a bit extend it. We have has a credit, is active or not, balance, customer ID, number of the product, and tenure. For demographic, we have churn or not, we have gender, age, customer ID, location ID, and salary. And for location, we have two columns. One, geography, which is country, and the other one is location ID. I'm going to create a data model. The first thing is that I'm going to make a join in a physical table for demographic and location to create one single table, and after that make a relationship between that table and account. So I bring demographic here, and I go inside the demographic because I'm going to make a join to bring the location instead of the location ID. I select location and drag it here. If I go with update data, we have data right now. If you see, this is exactly inner join. Just because I have all the customers, regardless they have location or not, I go for left join. However, our data is pretty clean and neat just because they are coming from the database. And it makes sense, the data is super clean because even in the database, they have the data model. So we have customer ID, gender, age, salary, location ID, churn, again, location ID from location table, and geography or country. Now we have the demographic, but this is the logical table. The physical table is coming from two tables, demographic and location. Now it's time to make a relationship between the demographic and account. And as you can see, these data are related to each other based on the customer ID, which is key. You see the demographic, if I extend it a bit, customer ID from demographic equal customer ID from account. Okay, before doing anything, I would like to just make sure about the data type. Again, this data is coming from the database. We can make sure about the data type, but it's not hurt if we see the data type here. Customer ID, however, this is labeled, but just because they have the number, I can say this is a numeric, that's fine. We have gender, we have age. Gender should be a string. Age is a number as an integer, as a whole. We have salary as the decimal because we have some decimal number. We have demographic ID, or we have location ID from demographic. We have churn, it is just a Boolean, true or false. We have location ID here, and we have geographic. Some columns I don't need it. I can just hide it when I go to making some charts. I have very clean and very minimal column. I don't need location ID. I just hide it. Again, I don't need this location ID, and I just hide it. The rest, I need it. I need the geography for country. I need the churn, definitely. This is the most important target for this project. We need the salary. For the age, I don't think so we need it, but let's have it. After that, if we don't need it, we can just hide it. For gender, we need it. And for gender, I guess, again, we don't need it, but let's have it. And customer ID, we need it. And account. For account, again, we have customer ID. I don't need this customer ID. Balance, number of the product, has a credit card or not, and is active or not. Now, if I go to the worksheet, the data is here. We have two tables. We have account and we have demographic. In account, we have two Boolean, has a credit card or not, and is active, and three numerical columns, balance, number of the product, and tenor. In demographic, we have churn as a Boolean, customer ID, gender, and geography. Also, we have age and salary. Those are my numerical columns. Now data is ready to create our dashboard. For creating a dashboard, before create a whole dashboard, I prefer to create every single chart in different sheet or workbook. After that, we can aggregate all of them in a one single dashboard. Okay, based on our stakeholder needs, we don't need two columns. We don't need age, so I just hide it, and we don't need number of the product. For this specific dashboard and for this specific problem, we don't need it. It doesn't mean for every single requirement for this project, maybe in future we don't need it. They are stored in a database, and whenever we need it, we can just pull it. As you can see here, churn here is true or false. It means if I put it there, this is false or true. But we need churn as a number. So we need to convert this Boolean number as some number, 0 or 1. 1 means churned and 0 means not churned. So for doing that, I should create a calculate field. So I go to the data and create a calculate field. And I call it as the churned customer. And this is just a simple formula. If churned is equal true, then 1, else 0, and then end it. Very simple. If churned is true, put 1, otherwise 0, and end it. And I call it churned customer. Now you can see we have one more numerical column for demographic. This is churned. If I put it right now in the text, you see instead of true or false, we have number. It means out of 10,000 customers, this is length of our data set, 2,037 of them churned. So this is the measure whenever during every single chart we need the churn number, we should use this measure instead of the churn true or false. So based on our mockup, we need at the first chart, let's review our mockup. For the first workbook, we need two numbers. One number should be number of the churned customer, and the other one number of the total customer. So we need two numbers here. So I come back to the Tableau. And first of all, I need to find number of the churned customer. We created it, so churned customer, just because we need some kind of text or the band, I put inside the text. We have 2,037. What about number of the customers? You see we have customer ID, so every single of them is counted. And I put again as a text, and you see we have something like that, but it's not something that we needed. We need to count it. I go for customer ID and go for measure, and we need count distinct. Now this is 10,000. So the first workbook is ready. Don't worry about the text, the labels, the design. I don't like to work on the design and these kind of things at this moment. First of all, I'm going to make all the charts, and after that, I can do the designing or any of these tasks to beautify the dashboard. Okay, the first sheet is ready, and let me call this sheet. I call this sheet as a number of, number of churned. This is number of churned for the first sheet. Okay, for the second sheet, I'm going to create one bar chart, distribution of churn by country. As you know, we have country here as a geography. If I put the geography as the column, and we need number of the churned. So again, we need the churned customer. I put churned customer in the row. This is very simple bar chart. We have every single country, and we have just sum of the each for the churn. I'm going to put the churn as a label. So I go for the label and check to see the labels. And even for design or the color for each of them, I can put geography inside the color. Every single country has its own color. This is very simple. Again, this is not very beautiful, just because first of all, I'm going to make a structure and after that beautify our dashboard. So let me call it churn by country. Okay, the next visualization is churn by continent. But we don't have continent here. We just have the geography. How we can create the continent? For doing that, I right-click on a geography, go to the create, and go with group. Here I can call it as a continent. And I can just categorize and group this country based on the continent. For example, I can say Canada and USA, they are going to be in North America. And France, Germany, Spain, and UK, they are in Europe. These are my two continents, North America and Europe. I apply and OK. Now we have continent here and we have geography here. I would like to make a hierarchy because geography or the country should be underneath the continent. I again right-click on a continent and go with hierarchy and create the hierarchy. I can say location. Inside the location, I have continent. I can just simply put the geography or the locations or the country underneath that. So inside the location, I have continent and I have geography. It is very useful when we want to drill down on a data. The process is same as the churn by country. I put continent for the columns and churned customer for the rows. The process is exactly the same. Again, I go for label and put again, that's fine. And for continents, I put inside the color. North America is just orange and Europe is blue. I can call it churn by continent. It is ready. Now we can go for the next visualization. Okay, next one is we are going to make a pie chart, churn versus the status of the account. Because we saw in a hypothesis test and a statistical testing that opening accounts and or closing the account is super associated with the churn customer. So this is very useful KPI and it makes sense. We have that KPI in our dashboard. So I go to Tableau again. We need to work on two columns, is active and churned customer. Is active, I put on columns, and churned customer, I put it here. But we need pie chart. I go for show me and create as a pie chart. For labels, I'm going to show the labels, and that's it. We have just a legend. We have false, means they close the account, or we have true, means they are active. Again, we can create some calculated field to change false to open or close. But for this particular project, I prefer to go with this default and this configuration. And I can call it churn by account status. Okay, we are ready to go to the next visualization. Next visualization is again a bar chart, but this is the horizontal bar chart. We are going to see the tenure and churn by customers. If you again remember the statistical testing, we noticed that tenure is very important for the churn customer. What I'm trying to say that making a dashboard, it's not just whatever we want we should put in a dashboard. We only should bring those ones that during the project from the scratch, from the statistical testing, exploratory data analysis, in SQL, machine learning, all these kind of things tell us which kind of KPIs are most important. So for tenure, I put tenure for the rows. And now, just because I'm going to make a bar chart, I need one categorical. Tenure is numerical, okay? But I can't use churned customer because again, this is numerical. This time I should use this churn, true or false, as a column. It means true means they churned, false means they didn't churn. I would like to change it to this way. as the horizontal bar chart. Churn false and churn true. You see, for those ones, they churned, if I put the label, almost 10,000 tenor in terms of the year for all customers, 10,000. But you see, those are the churned. I can say they are almost 25% of those people, they didn't churn. It's a very good hint for the managers that if they're going to work on tenor as a KPI or as a metric for keeping the customers not leave the bank, I guess 10,000 tenor is so high, and they should make some campaigns and take some actions about it. So I call it churn by tenor. And we can go for the last visualization. Okay, the last visualization is financial information and relationship with the churn. If I go to the Tableau, let me create one more sheet. I need two financial information here. One of them is balance, I put in a column, and the other one is salary, I put in a row. Just because both of them are numerical, I will have some kind of a scatter plot. But inside it, I would like to put all the customers. These are all the customers inside this scatter plot as a balance and salary. It means balance and salary, the shape shows us the scatter plot. They have nothing to do with each other. That's very interesting because everybody thinks if they have more salary, maybe they are going to have more account balance, but it's not showing like that. It shows maybe they have good salary, but they are not investing that salary in our bank. Maybe it is a good hint for managers to, convince them just because you have high salary, you are probably have more money. So bring those money to our bank. Because I see, for example, this client, the salary is almost 200K, but the balance is less than the salary. So it means this client probably is using another bank for saving the account. And this client is so interesting. This client, the salary is 81,000, but the balance is 250. It means this client is definitely using our bank, and whatever she's making, she's just saving in the account. And vice versa, this client, you see, salary is almost 200K, but the balance is almost 3,000. These customers probably withdraw the account. But in terms of the churn, let's see if I put the churn as the color. You see, this customer that we just talked about it left the bank, and it makes sense. Why? Because the balance is so small and the salary is so high. It means this customer was not happy with our bank and they left the bank. But this customer was so interesting. They have good balance, and she made a decision to leave the bank. So it is very weird for the bank because, it shows based on a salary, she was investing, she was saving the money in the bank, but maybe all of a sudden she decided to leave the bank. If the managers want to know why, they can come back to the statistical testing that we talked about it. There are a bunch of variables in there, and to see the association between the variables, to see maybe, I don't know, maybe the tenor is very important here. Okay, for the shape, let me just change it to this way. Okay, this is the last visualization that we made it, and now we are ready to create our dashboard to concatenate all together as a one single page for managers. Okay, I'm going to make a dashboard. Before creating a dashboard, I should create the foundation and the structure for the dashboard. First of all, I'm going to set the size. It should be fixed size, and the dimension is 1200 for width, and height should be 800. Based on the mockup, we need text we need 3 blocks as a block for the visualization. So I'm going to create the structure and foundation, and after that, put the visualization inside it. So I first put the text or the title. It is the title for the project. You see we have the title. This is a title. Let me just make it a color. These are just for making distinctions. After that, I beautify. Next things, I'm going to have the vertical container. I put the vertical container, one container, just this color. And another container, I put just, before doing that, let me just make it small. Here, this is another. If I go there, we have one as a title. The other one is the blue one. And the next one. Now we have title, this line, and that line. Inside each vertical, I'm going to create 3 blocks. 1, 2, 3. Let me just make them a bit distinct. This is the first one. This is the second one. And this is the third one. Now for this one. Again, I go to the blank, first one, second one, and third one. The first one is this color, second one is this color, and third one is just white. There are 3 different boxes for each vertical. Now we build the structure and foundation of our dashboard. Okay, now I'm going to put my visualization inside the container. This is the first one. The second one is just a chart for dashboard and the continents. If I go there, just see the tile. All of them are here, except, let's see, this is continents. This one should be here. Okay, this one is wrong. Okay. Again, where is it? This is the first one. Should be here. Okay. So I don't need this one, that one, and that one. I don't need also this legend because the chart has its own. Okay. The next one is the last 3. This is the first one, the second one, and the third one. And I don't need the blank one also. This should be here. And I don't need this one anymore. Okay, this is the dashboard, but it's not very beautiful. Now I'm going to make it a bit better in terms of the designing. So I pause the video, and after that, I show you the final result. All right, this is the final dashboard. Maybe I'm not very good at designing, but just for purpose of this project, because this project is gonna be a full and end-to-end data science project, I try to do my best, but definitely if it was a real project, definitely it was super different. It was a bunch of data elements, however, based on a requirement. This is just because of the project. I try to do my best. Let's see. As a final result, you can see we have the title, we have number of the churn people, total number of the customers. We have churn by country, churn by continent, churn based on account status, churn by tenor, and financial data. And it is super interactive. If I just select in Canada, we only see in Canada just 336 people churned out of 679. It makes sense it is in North of America, and it is just a distribution based on account status. And if I go for UK or even just Europe, and maybe just the account status for those they are churned, we have just 735. So this is just a Tableau for data visualization at the final stage of our project. I hope you enjoyed this end-to-end data science project. In this project, I tried to show you how we should step in a real-world scenario in a data science project. We went through the data understanding, the problem understanding, which is the crucial and initial step for the project. After that, we go with data documentation. Then we went for the data modeling, data cleaning, exploratory data analysis with SQL query. Then coming back to several a bunch of Python scripts to work on data. After that, we go with statistical analysis. Then we come back to Python for making the machine learning project. And after that, we went for data visualization. This is the life cycle for the project, and this project is super modular. It means even right now, when data is changed in a database, the statistical analysis would be updated, machine learning model would be updated, and even the data visualization. However, if we want to work as a very real scenario, we should go with some DevOps or MLOps, create some CI/CD pipeline. Those things are beyond out of scope just as a project. All of them should be done in a real world scenario, and it needs different teams. I hope you enjoyed this video. If you want to download the materials for this project, please use the link in the description of this video. And I hope see you soon in the next project. Thanks for being with me in this long journey for this end-to-end data science project for churn prediction.